Hey, welcome everybody. My name is Caleb and this is your Bitcoin course. We're going to be talking about pretty much everything you need to know to get started with Bitcoin and understanding the confusing concepts around it. Now, if you've studied Bitcoin at all, you might find it really confusing. And I have gone the extra step to try to break down these principles as much as possible in a way that anybody can understand them. So whether if you're brand new or you have some experience with Bitcoin, this course should work out for you and help you along the journey. So let's talk about some of the things we're going to talk about. First off, we're going to get the ball rolling, just understanding what Bitcoin is and how it works at a basic level. So at this point, I want you to be able to have a simple conversation with somebody that you meet at a tech conference, or maybe you meet them at lunch, or whatever it might be. I want you to feel like you understand how Bitcoin works. At this point, you're not going to know all of the details and have this master understanding, and that's totally fine. The point here is to build that foundation so we can start looking deeper at all the different pieces. We will then move on to understanding Bitcoin as a currency, look at some of the pros and cons of Bitcoin in comparison to other currencies we might be familiar with. Once we got this down, we'll take a look at the blockchain and understand how it relates to Bitcoin, how it works, and some of the main things you need to understand around blockchain to understand things like Bitcoin or all the various other applications of blockchain technology. Then as we move on to understanding Bitcoin mining, we're going to be talking about binary and hexadecimal, how these things work. We're going to look at hashing as well as cryptography and some of the more technical things around Bitcoin and blockchain. We'll approach these with general concepts and then apply them to Bitcoin to see how these different things are used in the context of Bitcoin and the Bitcoin network. At this point in the course, you should have a pretty good understanding of Bitcoin mining and how that works and all of the different pieces around that. You should be able to understand them and know where they fit in the context of Bitcoin. We'll finish off the course just looking at the Bitcoin landscape, looking at some of the altcoins and the different things you need to know about when it comes to Bitcoin and blockchain. So maybe you've heard of things like Bitcoin Cash or Ethereum or Ripple. We're going to look at these and see where they fit in. So overall, you're going to be getting a lot of information from this course, and I am really excited to share it with you. Bitcoin and blockchain is an ever-evolving technology, and I'm excited to join you for the journey. Let's get started. Hey, what's going on, everybody? Welcome to your Bitcoin course. First off, I wanted to say thank you for joining me on this journey. I'm excited to go through everything Bitcoin with you guys, whether you're coming from like an economic standpoint or maybe the technology standpoint, or like a personal finance, you want to know about the investing and making money with Bitcoin, whatever it might be, understanding Bitcoin and how it works, that's what I want to teach you, and it's going to be valuable whatever field you're coming from or whatever you might decide to do with Bitcoin. So where do we even start? What even is Bitcoin? And we're going to be talking about what Bitcoin is all throughout this course because it can take a little bit of time to kind of wrap your brain around the concepts, but essentially Bitcoin is a digital currency, or what most people call a cryptocurrency. And when you look up Bitcoin on the internets, you can see it has a price. So one Bitcoin equals this amount, 9,800 some United States dollars. Now, if you're using a different currency, that's fine. If United States dollar isn't your primary currency, the content in this course will work just fine. Just understand that's my currency, so that's the standpoint I might be talking from when we're talking about currency conversions or whatever. And if you look this up, you'll probably see a different number because of the volatility of Bitcoin. So the price changes very frequently and it changes by large amounts. So you never really know what price Bitcoin is. I just did a couple Bitcoin videos not that long ago and the price was 8,000, and then I saw it go down into the 7,000s, and then I saw it pass 10,000. So it's always changing, and people capitalize on this by making investments and getting huge returns, but people also lose a lot of money doing this because they invest at the wrong time, they buy a bunch of Bitcoin, and then it tanks in value and they lose money. So when it comes to an investment, you always want to approach Bitcoin very carefully and be vigilant, as you never really know where Bitcoin's going to go. And with any investment, you shouldn't invest money that you're not aware that you might lose. So don't be investing money you need because the value could go down and you could lose that money. Also, when it comes to investing, you don't want to invest in anything you don't understand. Some people are immediately going to tell you that Bitcoin is a bad choice when it comes to spending your money And that's not necessarily true if you understand the principles behind Bitcoin and how it works. So that's a little bit to touch on the financial aspect of Bitcoin. Basically, you buy at a certain price, and then later down the road, you can sell it and get back your United States dollar or whatever currency you use on the day to day. When it comes from a technology standpoint, Bitcoin is actually very important because it introduced a popular technology now known as blockchain. And this is essentially a type of distributed database that allows us to make all kinds of crazy applications without a centralized entity. And that's a bunch of jargon that we're going to break down throughout these episodes. But essentially, Bitcoin allows us to have a currency without one central entity regulating it or making new Bitcoin. The responsibilities that a centralized entity might have had with the current financial system, in Bitcoin, these responsibilities are actually distributed to all of the nodes in the Bitcoin network. So we're going to get into what all of that means in the upcoming episodes, but from a technology standpoint, Bitcoin is one of the coolest new technologies that probably has the most potential to really change the world and how everything works. So that's your introduction to Bitcoin. And what I would encourage you to do is just look up Bitcoin, and when you go on here, you can see more on the Wikipedia page, but you can also look up Bitcoin price, and you can find different charts. So for example, this Bitcoin price index, this is going to show you the price of Bitcoin over time or for a particular date range. So just today, it started at 9,000 something and 9,879, and it went down to 9,700. So it went down like $100, but you can really see the differences in value when you zoom out a little bit. So if you look at a year, you can see there is quite the change here. It started out that's pretty low. So February 22nd, so a year ago from today. It's actually a little tiny. I'm gonna zoom in here. I'm like scrolling my eyes in as far as I can. I'll try not to do that. So a year ago today, there was the price of 3,800, and now we're up to 9,000, almost 10,000. So the price is extremely volatile, and you can see completely, if you go all time, the value at one point was nothing, and it ended up picking up value and growing, and then you can see there's various spikes in here. For example, there's this very large spike. There's this famous time frame where the price of Bitcoin was 20,000, and then it immediately went back down, and people were like, oh no, is it finally crashing? I don't know. But then the price actually started to go back up, and now it's kind of doing the same waves. And I think part of this volatility is because it's a new thing. So I kind of think of it as like a tech startup, right? When a tech startup starts, they might have months or years where business is booming, people are talking about them, and then the next couple months, maybe that's not so much the case. And over time, those ups and downs kind of stabilize, and things become a little bit more normalized. So the highs are a little bit lower and the lows are a little bit higher, a little bit more predictable. I'm assuming that's what's going to happen with Bitcoin, but we can never really tell. Nobody knows the future or what the price is going to be in a year from now or 5 years from now, but I think we're all curious. Now, another cool thing we're going to be using throughout this course is a blockchain explorer, and I'm just going to show you the absolute basics of this right now, but you can find it at blockchain.com/explorer. This is one of the options out there, but there are other explorers, and this will allow us to take a view of the technology behind Bitcoin and see how things work. So you can see all these different blocks is what they call them, and inside of these blocks there's different information. Specifically, there's a bunch of different transactions, and this is actually chained together in like a linked list data structure known as a blockchain. So behind the scenes, Bitcoin has a lot of technology we can talk about, and we're going to do that. But first off, I think it's more appropriate just to understand how to use Bitcoin, because it's kind of like the United States dollar or any other fiat currency, as we call them. So it looks like all I have is a quarter with me, and this can be used to buy things. And when you're really young and you're first starting to learn about money, you start to realize that the more of this money stuff you have, the more things you can buy. But you don't necessarily understand, where does this money come from? Who makes this? And how does this have value? Why did we decide to use these coins and these dollar bills? All of those behind the scenes things, you don't need to understand those to understand how to use a quarter. Well, the same thing applies with Bitcoin. You don't necessarily need to understand all of the details of the blockchain, block size, and the difficulty in Bitcoin mining, and all of these things. However, if you're going to start doing anything serious with Bitcoin, you need to understand those details behind Bitcoin. And it just helps to start learning about how to use it first, because if you've never seen a quarter before, and I gave you 1 million of them, you probably have no idea what that means. And same thing, if you had 1 million quarters, you might start to take your finances a little bit more seriously and understand how to protect your money, how to make sure that money maintains its value or grows over time, and all of these different things when you start getting into the money stuff a little bit more. So in the context of Bitcoin, we're going to first understand how to use it, how to get some Bitcoin, how to transfer it around, and then we're going to understand a little bit more about how to protect it and how the technology behind it works so that you don't lose that Bitcoin, or so that you don't understand it incorrectly and end up getting scammed or confused and losing it. We don't want to do any of that stuff. We don't want to lose our Bitcoin. So we'll start with the basics and then we'll go a little bit deeper in the juicier substance. So I'm actually super excited. I've been looking forward to doing this course for a long time, and I put a ton of information together, so I'm really excited, and I hope you guys are as well. Stay tuned for episode 2 because we're going to be talking about something. So see you then. Hey, what's going on, everybody? In this episode, I want to give you a little bit more details on what Bitcoin is. So the previous episode, we did an introduction. We talked about that it's a cryptocurrency and that it uses this thing called a blockchain. But now I just want to give you a little bit more substance so that you can hold a conversation talking to somebody about what Bitcoin is. So where do we even start? Well, first off, pretty much any website about Bitcoin, you'll see some other stuff floating around. So for example, on this CoinDesk price chart for Bitcoin, you can see some other stuff. We see Ethereum, we see XRP, we see Bitcoin Cash. These are all examples of cryptocurrencies. So you can kind of think of them as the competitors to Bitcoin. They might work just a little bit different or have different features or different things that make people want to buy them. But at their core, they work very similar to Bitcoin. They're using a blockchain. They just might have a couple of variations in how that blockchain works. But they're also going to have prices, and they're also going to be able to be traded amongst people. So should you jump in and learn all of these different cryptocurrencies? Maybe in the future you can study each one in a little bit more detail to understand their selling points and what makes them unique. However, the underlying technology and the concepts you're going to get from this course in Bitcoin, it's probably going to apply to all of these cryptocurrencies you see. So if you finish this course, you'll probably understand how Ethereum works. And then what you can do is you can go study Ethereum and just figure out these minor differences between Ethereum and Bitcoin. But you already understand the blockchain, you understand how all that works, and you'll be good. So my recommendation personally is just to start focusing on Bitcoin, and then after you got Bitcoin down, you can learn the altcoins, which altcoin is just a common name to talk about the coins that are not Bitcoin. Bitcoin kind of set the stage for all these coins. It's the OG cryptocurrency. It's the one that started this trend. It's the one that blockchain was invented with. So Bitcoin is the place to start. Just spilled water all over me, darn it. So when Bitcoin was announced, it was announced through a white paper. And you can see that here. You can find it at bitcoin.org/bitcoin.pdf. And if you are interested in a lot of the details of what made Bitcoin come to be, you can go through this white paper and read it. However, I'm just going to call out a few things throughout this course from this white paper that basically brings these concepts from this white paper into reality. So hopefully we can touch on some of these things and you'll have a better understanding of Bitcoin because of it. So the very first thing you understand is that it's a peer-to-peer electronic cash system. So the whole idea with cash is that if I take physical currency, cash. I mean, I guess it's not paper cash, but a coin, I can give this to you and buy a lollipop or whatever you might be selling. So I give that coin to you and you give me something in return. And there's no middleman managing the exchange. But when we talk about digital money, there's always someone in between that exchange. So if I buy something from Amazon, I have to use a credit card or a debit card. If I buy something from you and I send money to you through Apple Pay or Venmo or just PayPal, well, that exchange is facilitated using those services, so Apple or PayPal. The whole concept behind a peer-to-peer electronic cash system is that we want to make the same system where I can give you money directly without a third party, but we want it to be electronic. So that is the problem that Bitcoin is trying to solve. How can I give you money through the internet without going through a bank or a company such as PayPal? And that's exactly what it's saying here in the abstract. It would allow online payments to be sent directly from one party to another without going through a financial institution. So when you send money to someone online or you're buying something, there's a lot that goes on behind the scenes, and the purpose of Bitcoin is to bypass that. The current financial system, the way it is set up, it's built upon trust. We are trusting this third party to process our payments and make sure everything goes well. We also have to have trust in the other individual we're working with. If I'm selling you something or you're selling me something, we have to trust the other person in that exchange. We have to trust that they have the money. So if someone writes me a check, we're making a trust assumption that that money is in their bank account. Or we trust that this person is not going to call their bank and be like, yo, I got scammed, can you cancel this transaction? And then they keep the item we sold them. So as a vendor who accepts Bitcoin, I wouldn't have to worry about the person canceling the transaction because they can't just call their bank and cancel it. Once I get their Bitcoin and they get the item, it's essentially permanent unless I send them back their money in exchange for the item. So we don't have to trust that other individual at a personal level. We just have to trust the system that allows us to transfer money, aka Bitcoin. We trust Bitcoin, we trust the blockchain, and then we don't have to trust the bank or the person we're doing business with. It's kind of like the way a contract works. You know, maybe back in the old day, a good handshake was all we needed. But as people did not fulfill the requirements for the handshake, people started being like, oh, I don't really like this handshake thing. So we introduced the contract. Now we write down what happens from one person and how much the person's going to get paid from the other person. You can apply the same thing with Bitcoin. So you can kind of think of it as these transactions are miniature contracts. I sell you a service and you pay me Bitcoin, and that is written in the blockchain for everybody to see. So in a blockchain explorer, you can go into a block and see all these different transactions. They're kind of just like miniature contracts where one person pays another person for a service and it's written down on the blockchain. Bitcoin gets even more confusing because the system to allow these transactions to be confirmed, the blockchain, is a very complex technology. At least if you're brand new to it, it can seem very complex. But essentially, this peer-to-peer network is made possible thanks to a distributed system. And by distributed, it's just another word that means not centralized. So it's the opposite of centralized, such as a centralized entity like a bank. So we actually have a bunch of computers all over the world contributing to this system. And these computers are competing through a process known as Bitcoin mining. And you don't need to understand what Bitcoin mining is or how it works right now, but we will talk about that by the end of this course. But what Bitcoin mining is, essentially, if we give you like the 15-second crash course, is a bunch of these computers competing to confirm transactions into things known as blocks. So they put these transactions in the blocks, and they want to be the official person to put this block on the official blockchain, which you can see on a blockchain explorer. For example, this block right here, this was submitted by somebody, and this person gets a reward in exchange. So that is essentially how Bitcoin mining works. But basically, this distributed system allows us to not have a centralized entity like a bank. So to wrap that up, Bitcoin is peer-to-peer and it is distributed. Peer-to-peer meaning you can send money from one person to another, and distributed meaning that the network has a bunch of different nodes instead of one central node, such as a bank. So taking a look back at the homepage of a blockchain explorer, you can see this column here that says hash and it has these numbers. Well, each one of these is a block, and a block contains numerous transactions. So we kind of just group things together. Rather than each individual transaction being a thing, we group them in a group of like a few thousand, let's say 2,000, and this block then gets a hash, which has to do with cryptography, and we'll get into that once we talk about the technology. But if you open one of these blocks, the transactions that are a part of this are seen at the bottom, and you can see where they came from and where they are going, as well as the amount. So for example, 0.72 Bitcoin. So if you had to visualize it, it'd be something like this, where we have numerous transactions in each one of these blocks. So now, instead of me paying you a quarter for a lollipop, one of these transactions inside of these blocks is going to show me transferring 25 cents worth of Bitcoin from me to you. All right, so that was a lot. We talked about what Bitcoin is and a little bit about how it works, but now I want to focus purely on how it works in the sense of how is this a sustainable form of money. So that's what we're going to be talking about in the next episode. All right, so you guys got your introduction to Bitcoin, and we even talked a little bit about what Bitcoin is and how it works, but now I want to talk a little bit about it in more detail. So yeah, it's kind of like this thing where you have an introduction and then you have like a little bit more and then a little bit more, and you just keep getting these slices until you understand the full concept. So the previous episode, I showed you guys this illustration where we have these blocks and they are linked together in a data structure known as a blockchain. I want to talk a little bit more about how Bitcoin as a currency is going to work. The very first thing is we remove trust, which I talked about this in the previous episode. So if I give you this coin, you take it, it's now yours. And this works, but when it comes to digital currencies and trading money digitally, well, there's a lot more complexities. For example, you can call your bank and say, hey, can you cancel that transaction? I got scammed. It wasn't me. You can lie. And these things make the financial system as is very complex. And there's a lot of trust based in this. We trust the bank. We trust the consumers. Bitcoin removes this trust and goes back to the way cash works. However, it's digital. So it's the digital cash. With cash, you know that once I give you that money, we cannot reverse that transaction unless you give me that money back. The Bitcoin white paper explains it like this. With the possibility of reversal, the need for trust spreads. Merchants must be wary of their customers, hassling them for more information than they would otherwise need. A certain percentage of fraud is accepted as unavoidable. These costs and payment uncertainties can be avoided in person by using physical currency, but no mechanism exists to make payments over a communications channel without a trusted party. A communications channel being the internet. And basically, he is saying that the system is fine when we're using cash, but we want to use digital currency. How do we have the same benefits of cash, but now digital? That is the problem Bitcoin is trying to solve. In order for Bitcoin to work the way it wants to, transactions must be irreversible. Meaning, if I send you money, there's nothing I can do to get that money back unless you go through the effort of sending the money back to me. And it works the same way with physical currency. As a result, once these transactions go on the blockchain, and you can see them here, this is immutable. We cannot go back in time and change or cancel any of these transactions. It is permanent. Now for this blockchain structure with all of these different transactions, instead of just thinking of them as blocks, think of them as permanent blocks. So think of them as the bedrock of Minecraft, or think of them as concrete you cannot destroy. And the blockchain just keeps getting longer. So I'm going out of frame here, but over time, we just add more and more blocks and that data is permanently available for everyone to see. So a particular transaction, such as this one here, there's nothing that person can do to go back and change the value or change the person they're sending the money to or cancel it. The lesson learned here is that don't send your money to the wrong person because you cannot get it back. If you get scammed, you're 100% scammed. There's no way to fix it. There's a lot of scams out there when it comes to wire transfers. So for example, if you're buying a house and you need to pay that down payment, scammers will try to pretend to be somebody else and give you incorrect transfer information so that you send that money somewhere incorrectly. However, with a wire transfer, if you accidentally send money to the wrong person and you catch it quickly enough, there's a chance that you can undo that and get your money back. With Bitcoin, there's no way to get your money back. So there's a lot of additional responsibilities that are put on yourself when you're dealing with Bitcoin. And I can explain why. We're going old school drawings here. When I send you money, it goes through a third party. And that third party has responsibilities. You can think of it as outsourcing the money management to this third party. If we get rid of this third party, these responsibilities, some of them are given to me, and some of them are given to whoever I'm sending money to. So we no longer have that third party to hold our hand, which means we actually need to take control of our money and be responsible, because now we have more responsibilities. So now when I'm sending money to you directly, I gotta be a lot more careful. So a core attribute of Bitcoin and the blockchain behind it is that it is immutable, essentially. And I say essentially because from a functionality standpoint, it's immutable. You can't change it. But from a technology standpoint, it is possible to change it, but in normal circumstances, it should not happen. So if someone found a bug in the code or were able to hack the Bitcoin blockchain, then there is the possibility for reversing a transaction or changing the blockchain. However, it is extremely, extremely difficult, and the incentive to do it is not really there. So from a consumer perspective, it's immutable, it's not going to change. From a technology standpoint, it's technically very, very difficult to change, but not 100% impossible. So the reason why it's technically very difficult to change the blockchain is because the blocks are cryptographically connected. So this block here, if you were to change the data in it, you would also need to change this block, and this block, and this block, and any block after that one. That's because the block data is hashed, and that hash is an input for the next block. So if you changed that block, it would change the hash, and it would affect every single block after it. So there are various issues we could talk about when it comes to blockchain security. For example, there's different attacks. There's like a 50% attack and these other forms of attacks that make blockchain have issues. However, these issues are being ironed out, and over time they become less and less of an issue. So we can start to trust Bitcoin and the blockchain a lot more over time. Now, the last thing I wanted to mention in this video is that Bitcoin is open source. So you can see all of the code for how this works on GitHub, and people contribute to this. So you can go in there and you can read the code. It's in C++ if that's something you're into. This level of transparency to me is important because if I'm just going to put my trust in this Bitcoin network, I want to know what is going on. And that's one of the benefits we get from Bitcoin that we're not going to get from the banking system. Unless you maybe do a ton of research or you work at a bank, you really don't understand what's going on behind the scenes, and you just assume that paying somebody money, it's gonna work. But now, all of this is made open source for us to see, so we can see exactly what happens when we transfer somebody Bitcoin, assuming you can understand it. However, if you don't understand C++ or coding, you can be assured that the fact that anybody can go in here and read it, and the system is still structural and people are still using Bitcoin, there is a level of trust that is built there. Because a lot of the people could go in here and read this, and people would stop using Bitcoin if there was something sketchy about it. So that is all I got for you as an introduction to Bitcoin, how it works, what it is, all that junk. Now we're going to actually start using it. So I'm really excited, so stay tuned for the next episode. All right, so you guys are finally ready to get your own Bitcoin. You want to get your hands on this stuff and start using it. That's what I'm going to be showing you guys in this video. And people suggest getting your first Bitcoin in various different ways, so you might hear different ways from different people. My suggestion, and personally this is what I've had the most success with, is to trade my fiat currency, which is a fancy word to say money that doesn't actually have any physical value. It's just established as the default currency for a particular country. So USD is an example of a fiat currency, United States dollar. And you can trade your fiat currency for cryptocurrency through something known as an exchange. And then once you have your Bitcoin from this exchange, you can transfer it out of the exchange into your own wallet so you're no longer relying on the exchange. Some people do not like this method. Why? Because we're kind of relying on a third party. So we're getting rid of the banks and we're getting rid of these money transferring systems, and we're replacing them with an exchange which kind of does the same thing. So it seems a little bit silly. However, the end goal is not to rely on this exchange, but instead get your Bitcoin and transfer it out of the exchange, which I'm also going to be showing you guys how to do in this course. So personally, I don't have a problem with it. I think the exchanges make it very easy to get started with Bitcoin. There's a few downsides to the exchange though. One, you have to give them personal information. So probably your social security number, maybe a driver's license photo. And the reason behind this is because of certain laws known as KYC laws, Know Your Customer. So supposedly these exchanges have to keep record of this information because of like the government or whatever. And on occasion, they will share this information with the government. So basically, the government doesn't want you to have unregulated money that you can just buy stuff without paying taxes and so forth. So that's one of the downsides of using an exchange. You have to trade your personal information. There have been situations where hackers have broken into these exchanges and have taken people's Bitcoin, and as a result, people have lost a lot of money. So not only are you giving them your personal information, but you're trusting them to take care of your money. So it could be that in the situation of a hack, maybe your personal information is at risk, or your savings in Bitcoin are at risk as well. So in my opinion, you should always try to find a trustworthy Bitcoin exchange that either has really good track record or some forms of insurances or just really good reputation, whatever it might be that makes you comfortable. Try to find that in an exchange. I personally don't worry about it a ton because I'm not working with huge amounts of Bitcoin, and if I lose it, it's really not the end of the world, and it's a rare occasion. It does happen. So you don't want to leave thousands of dollars in an exchange, but if you're just working with like $100, you don't have to have that level of worry. So put in whatever amount you're comfortable, and then you don't have to worry about it. So if you need to start with $10 or whatever it might be, go for it. And then once you're a bit more comfortable, you can start working with larger amounts of money. Now, the other big way of getting cryptocurrency is to offer a service or a product in exchange. So essentially become a vendor that takes Bitcoin. Maybe you have a salon or a computer repair shop and you can take Bitcoin as payment. In that situation, you don't have to give out any personal information and those Bitcoins come to you directly. So that might be a little bit more of a secure option or a private option if that's what you're interested in, although it might be a little bit more work if you're starting out. Going back to fiat currency, when you first got money, you didn't really understand the concept of work and making money. You just got money probably as a gift and you learn by spending it. Then once you realize you can buy stuff with this money, you start thinking, how can I get more? And then you start selling things in exchange for money. So I personally feel like a natural progression is to start with an exchange, get that Bitcoin, and then you can start working with it. And if you find it valuable, then you can figure out how to get it as payment, and then you just go up from there. So all of that rambling pretty much just to say we're going to use an exchange and buy some cryptocurrency. So my exchange of choice is Coinbase, and when you log in, it's going to look something like this. Now, if you're creating a new account, you might want to try it out on mobile. I found that to be a very nice user experience. I had to take a photo of my driver's license, and it was nice just to have the camera right there, and it was really simple. However, you'll need to go through that process. I'm sure you guys can figure that out, and it shouldn't take too long. Mine took like an hour of waiting time for them to verify me. However, different people have experienced different wait times. Why? I'm not really sure. Maybe it has to do with your name. Like maybe if you're John Doe, they have a harder time. I don't really know. But anyways, once you get your account set up, it should look something like this. And when you get into here, you're going to have a portfolio balance. So this is Bitcoin that I have sitting in the exchange, and I'm trusting the exchange in a way I would trust a bank to maintain my money. I am not a person who's opposed to leaving money in the bank. I'm also not a person who's opposed to leaving a little bit of money in an exchange. However, if I had a large amount here, I'd probably pull that off of Coinbase and use a hardware wallet or something else. So we'll get into that later. But anyways, how do you get a portfolio balance? Because when you sign in, it's going to say $0.00. Well, what you do is you hit this trade button and you buy a certain amount. So you type in an amount, say where that money is going to come from. So I associated this with a bank account. Once you type in the amount you want to buy, you can hit preview, and it's going to tell you the fees. So unfortunately, there are fees whenever you buy or sell cryptocurrency, but the fees don't get real huge. I think up to like $3 or something. So you'll want to make sure you're working with enough that the fees are not just outrageous compared to the amount you're buying. So for example, if you're buying $2, 50% of that is going to be a fee. Nobody wants that. So with a $10 purchase, $9.01 is actually going towards Bitcoin, and this is the amount that I am going to buy. So obviously you can buy fractional Bitcoins. You don't need to have $10,000 sitting around. Thank goodness, because I wouldn't be here. And then once you're ready, you hit buy now, and that's going to go in your portfolio. Now, if you want to send this money immediately, you can see some information here. It says available to send in 4 days. However, if I change my payment method to a debit card or a bank wire, I can send that money immediately. So maybe if you guys are just starting out, you might want to use a bank card. So yeah, hit buy now, and I'm just gonna X out of this because I don't want to buy more right now. You can also sell here. So people always ask me, how do I take my Bitcoin and get that back into United States dollars? Well, what you do is you hit sell and you put the cryptocurrency you want to sell, Bitcoin, and you deposit it to Cash USD. And that's another number on your portfolio here. So you can scroll down, you can see that US dollars, you can hit that and then hit withdraw to go to your bank account. So it's a little bit more of a process, but you don't need to worry about that for right now. Just get some portfolio balance here. And then if you want more details, you can hit the portfolio tab, and that's going to tell you your assets. It's going to split it up by different cryptocurrencies. So I have US dollar, which is not a cryptocurrency. And then there's also USD coin. Don't get the two confused. I don't have any USD coin. I do, however, have $63.90 worth of Bitcoin. And you can see over here recent transactions on the right, or you can select a particular cryptocurrency and see the transactions, such as this one here. I got a Coinbase referral, and that's $10 worth of Bitcoin. Going back to your assets, you can see that you can buy multiple cryptocurrencies. So if you want to just have a broader portfolio, you can do that. All right, guys, so that is your introduction on how to buy Bitcoin. In the next episode, we're going to talk about how to store Bitcoin, so stay tuned. All right, everybody, this video should be pretty quick. We're just going to talk briefly about where you store your Bitcoin. So in the previous episode, we bought Bitcoin, and you can see it here on our Coinbase portfolio balance. So the first option is just to store it here. So anytime you store Bitcoin, you store it in what's known as a wallet. So even this portfolio balance here, it's made up of a bunch of wallets. So go into your portfolio and you can scroll down, you can see your different assets, and you have a wallet for each one of these assets. So if you go into Bitcoin, you can see we're actually in the wallet tab. So there's a wallet for Bitcoin associated with your Coinbase account. However, there's more than just this wallet. There's all kinds of wallets out there, some more secure than others. The problem with this wallet is that the wallet is associated with an exchange, meaning we are trusting this exchange with our private keys. And we haven't really talked about keys, but it's basically like the password for your wallet. It's the thing you don't want to share with anybody. Most of the time it's okay, but if someone hacked into Coinbase, there's a chance they might be able to get your keys and take your money from your wallet. So an important component of any wallet is that you should be able to send and receive money. So I can receive money here, and it gives you a warning here to make sure that the person sends Bitcoin to this wallet. And the reason why is because they'd be sending it on a different blockchain, and it wouldn't ever get to your Bitcoin wallet, and that person might lose all their money. So that's another risk you have. When we're working with United States dollars, we don't have to worry about all these different asset types or whatever. We just send people money. With cryptocurrencies, since there's so many different in the market, we have to be very careful that when we send Bitcoin, we're sending it to a Bitcoin wallet. Keep that in mind. So hit understand if you do, and the person who wants to send me money or Bitcoin will just scan this QR code if they are using an app, or they can use this wallet address if they want to send it another way. So this QR code is just a visual representation of the same address. So it just depends on how the person is sending me money. Same thing, if I want to send money, I can go and hit send, and then I can enter a Bitcoin address here. Then what I can do is I can say what I want to send. So I could say $10 as an example, or this certain amount of Bitcoin. I can write a note which gets attached to that transaction. So if you want to do that, here's where you would put that. Now, a thing you need to know is that anytime you do a transaction, there are transaction fees, also known as network fees. So it's so annoying. There's fees with everything. There's fees with Coinbase to get your cryptocurrency, and that's how they make their money. But there's also a network fee when you use Bitcoin. It's annoying because who likes fees? However, it's essential to making the Bitcoin network work. The fees, they're not just absorbed and they disappear. They actually go to the people that make the Bitcoin network possible. Through Bitcoin mining, if you were to confirm a block, you get the network fee for those transactions. So the computers or the nodes out there that make these transactions possible, they get rewarded these network fees, and they also get rewarded new cryptocurrency that goes into circulation. And it says on here, to avoid network fees, send to an email address. So if there's another person on Coinbase, they will absorb those costs or do whatever else to make that possible without any network fees. However, that's going to be to another Coinbase wallet attached to the exchange. It's not going to be a wallet off their network. In that situation, you have to pay those fees. So yes, the fees are annoying. However, they are important to incentivizing these different nodes to keep the Bitcoin network going. All right, so enough about sending and receiving money. Now let's talk a little bit more about the wallets, because that's actually what I wanted to focus on in this video, storing your Bitcoin. This wallet is attached to the exchange. I gave you the warnings about this, but there's other wallets out there you can use. So on the Bitcoin website, bitcoin.org/en/choose your wallet, you can go in here and you can hit next, and basically they'll ask you a bunch of questions and ask your priorities, and they will suggest different wallets for you to use. Anybody can make a wallet, so I could go in there, I could learn how to work with Bitcoin, and I could create software to store private keys essentially. Each wallet has its own unique things that you need to watch out for. So for example, some of them allow you to back up your keys. Others will use a seed phrase, which is a little bit different. Others have support for QR codes. Some give you a lot of customization, and some just are very, very simple. All those things are totally up to you. And not only will you have those types of variations, but you can have variations between platforms. So you could have a wallet for your desktop. You could have a wallet on your mobile phone. You can have a wallet literally on a piece of paper. These are known as paper wallets, and they just have the key written on them. The wallets don't actually store the Bitcoin. They're not like a storage container for the Bitcoin. Rather, they store private keys, which are kind of like your proof that you have permission to use that Bitcoin. It's like your passwords. So think of them as password managers more than a physical container for Bitcoin. So it can be a little bit confusing, but the only way a paper wallet would work, because obviously you can't store something digital in there, is if it's just storing your keys, which grant you access to the Bitcoin. So we're getting a little into the details here. What I want to focus on here is just finding a good wallet. If you're a desktop kind of person, go for that. Just make sure whatever you can do to back up your wallet or your keys, make sure you do that and keep it very secure. If someone gets your keys, say bye-bye to your money. It's sort of like giving out your bank account, username and password, security questions. routing number and account number, and 100% permission to do anything with the money. You don't ever want to give that information to one person. So the private key is like all of those put together. It gives pretty much full access to your money. So you don't want to give out your private keys. And you don't want to get your stuff hacked. So if you're on a computer and you got a virus, there's a chance you could lose your private keys and so forth. So just be really careful. So on this website, it gives you 4 different categories here. We got mobile wallets, desktop wallets, web wallets, and hardware wallets. My preference, at least for small amounts of money, meaning like the amount of money you would maybe keep in your checking account, mobile wallets, great. This is good because you can easily make transactions. It's good for everyday use of the Bitcoin. You're probably not going to keep thousands of dollars in your mobile wallet. This is more for day-to-day use. Desktop wallets, this would be a good alternative. I haven't really used desktop wallets. I started with mobile wallets and that's just been my thing. The risk here is that if you lose your device or your phone breaks, you are at risk of losing your funds if you don't do the appropriate backup measures. So watch out for that. Same thing with desktop wallets. Web wallets I have not really used beyond the wallet attached to my Coinbase exchange. That works for me, but I'm not going to go to another website to create a wallet. If that's something you're into, that's fine, but I am just too concerned for keyloggers or hacks for this website or whatever it might be. It's not something I personally feel super comfortable with, but you certainly can. And lastly, the most secure for large amounts of money, that is a hardware wallet, which is a physical device. So those are the types of wallets you can use. We're going to learn about mobile wallets and we'll get started with that. Hey, what's going on everybody? This is a continuation of how to store your Bitcoin, but this time we're going to be talking about a specific wallet, a mobile wallet that we're going to use to transfer our Bitcoin to and have it a little bit more of a secure way of storing our Bitcoin than just leaving our Bitcoin on the exchange. We've talked about the risks of doing that. You can weigh those if you want, but there's another benefit of using a mobile wallet, not just for the security of not leaving it on the exchange. And that benefit is that it's easier to use and it's ideal for transacting day to day. You know, in the future when everybody's taking Bitcoin, if you want to go buy a coffee or whatever, more than likely people will be using mobile wallets. Maybe, I don't want to predict the future, but that's what I can see being used the most. Now for a mobile wallet, it's going to be an app stored on your phone and the private keys are also going to be stored on your device. So you don't want to lose your phone, you don't want to ruin your phone, and you want to be careful giving your phone out to strangers if you have large amounts of money in your wallet. Another thing is that for the app that we're using, we're actually going to have what's known as a seed phrase, which is just a sequence of words that will basically be used to create all the private keys we need for our wallet. So if you take a look at the Bitcoin wiki, which we actually haven't talked about, but there's a wiki that covers pretty much everything you need to know on Bitcoin. There's an article about private keys, and you can see it talks here about a seed phrase, and it's basically a sequence of words that encodes the same information as private keys. So this is the thing that is going to be used to back up your wallet, and it is the thing you don't want to give out to pretty much anybody. No, just don't give it out to anybody. So if you get a new phone and you want to bring your wallet to the new phone, you're going to use that seed phrase to basically log in to your wallet. It's like your username and your password combined. So here's an example seed phrase, just a bunch of words in a sequence. And if you type in these words to your app to log in, it will open your wallet. So technically how this works is it'll be converted to a number, which is used as the seed integer. And a seed integer is kind of like the input for a generator to a deterministic wallet that generates all the key pairs used in the wallet. So all of the keys are generated from this one phrase of words. So a deterministic wallet is just a word used to describe this concept. It's a system of deriving keys from a single starting point known as a seed. So as for security, this will give you 128 bits worth of security, or in other words, 2 to the 128 possible inputs or different seed phrases. So guessing one is actually extremely difficult. So if you want to know exactly how many possibilities, that many. So that's the total possible number of seed phrases. A bunch. So in terms of protecting your wallet and protecting your money, the seed phrase is what you need to focus on, specifically who has access to it, and if you back it up how you're doing that, you need to make sure you're not storing it in a place that people can just find it very easily. So for example, you don't want to create a document on Google Drive called private key or secret seed phrase or don't read this, because those are the first things people are going to look for. Now the next logical question is, what wallet are we going to use? Because I've been talking a lot about it and haven't even mentioned it. And it's actually going to be, in this situation, the Coinbase wallet. Now you might be confused because we talked about the wallet that was associated with Coinbase. And maybe there's a bad naming convention here, I don't really know. But the wallet attached to Coinbase is part of the exchange service that they offer. The Coinbase wallet app is a different service that is local to your device and is not attached to the exchange. So the private key information, or I guess your seed phrase in this situation, is local to your device and no one has access to it. So when you look for Coinbase, you're going to find the Coinbase app, which is where you can buy Bitcoin and see your portfolio. And then there's the Coinbase wallet app, which is a separate wallet than the one that comes with your Coinbase account. So what you actually need to do is you need to transfer your money from the exchange to your wallet. Now here is the important thing you need to understand about this. So when we started with Bitcoin, we're bypassing the bank. And when you do that, there are added responsibilities to the people doing the transaction. So I need to be more aware of how I'm using my money and how I am protecting my money, because I no longer have that bank to help me out. So the next step I do is I start working with an exchange, which also does a little bit of management of my money to an extent. When I have my own wallet, it's a transfer of responsibilities from this exchange 100% to me. So if I screw something up, it's 100% on my head, it's nobody's fault. So if you left the money in the exchange, you can call support, maybe you forgot your username and password, they can help identify you and get you your account. If you forget your seed phrase or whatever it might be for your wallet, you're done. There's no support you can really call, and that responsibility for the money is all yours, so you are out of luck if you forget your seed phrase. Now this wallet is similar to the portfolio in the exchange because you can have numerous different cryptocurrencies on there and it'll just add up the values of them to show you your balance. Now one thing I did want to mention in this video before we start transferring money, again, remember that you need to transfer to the right type of wallet. You don't want to transfer Bitcoin to a Bitcoin Cash address, for example. It's a different cryptocurrency and you have pretty much 100% guarantee of losing your money if you accidentally transfer your money to the address of a different cryptocurrency. So don't do that. The second thing is that you don't really want to reuse addresses. So for example, on the wallet, you're going to have an address, and this address can be used for people to send money to you. And each time you receive money, that address is going to change. And that seed phrase is going to give us all the information to generate all the private keys for all of these addresses. So from the consumer perspective, using this app, you don't really have to worry about it. It's going to do it automatically. But just in general, you don't want to be reusing addresses. And we can go into detail on how this works. But essentially, it puts you at a higher risk and there's lower security and privacy when it comes to reusing addresses. An address is sort of like, we haven't really talked about addresses and keys a whole lot, but let me just explain it real quick. An address is similar to an email address, but this is a bad illustration for one reason. So you can use the address to send money to, but once you send money to that address, you need to use a new address to send money to the same person. So you're always going to be getting new addresses. This is different than an email address where you use the same exact one. The private key is more like your password, and your address is derived from this. So basically your seed phrase is where everything starts, it's the seed, and that can give you all the information for your private keys, which give you all of your information for your public keys, which give you all of the information for your public addresses. So yeah. It's a chain and it's a little bit confusing, but the things you need to know about are your addresses you use to receive money and the seed phrase, which you use to have access to the funds and basically proof that you own the funds and can spend them. So the next episode, we are going to do some money transfer. So let's get started with that. All right, at this point you have a pretty good understanding of how Bitcoin works, and I've given you about 1,000 warnings on how to not lose your money and all that stuff. But now let's just start using it. We are on Coinbase.com. This is where we bought our cryptocurrency, and now I want to transfer this to our wallet. So what we need to do is from the Coinbase.com homepage, we are going to either select portfolio or just go down to your portfolio down here and select a particular cryptocurrency, in this case Bitcoin obviously, and we're going to send this Bitcoin. Now the address here, this is the important part, this is where the money is going. It's irreversible. Again, I'm sorry I keep saying the same stuff, but just want to make sure you guys really understand before you mess something up. So you need to make sure this address is 100% correct so you don't send money to the wrong place. That being said, you can't just type in anything in here and have it go to somebody or a wallet, because not all values you put in for the address are valid. So if you put an invalid address, it's not going to work and you're fine. But if you mistype it and it happens to be a valid address, then you're going to send the money to the wrong place. Most of the time you're going to be fine. Just be really careful to put the correct address in here. And if someone sends you an address, the ideal way to do this is copy and paste the address versus typing it out, or use a QR code. If you're using a wallet on your phone, for example, you can send and you can take a photo of the QR code. It's really simple. So you take an address, you paste it in here, and then you select the amount. We'll say $10 worth of Bitcoin, and then you can put a message and then say continue. Then you just have to do two-factor authentication. So get a text message, type in that code, hit confirm. And now this is the part where the magic happens. What's going on behind the scenes? This transaction is announced to the network. So all of the nodes of the Bitcoin network, and anybody can be a node. You can go download Bitcoin Core and join the Bitcoin network. And this transaction hits these nodes, and these nodes can direct this transaction to Bitcoin miners. And you can be a node and a miner, or you can just be a node that directs traffic. But the miners are going to add this transaction to a block. So there's your transaction, it's in a block, and it's going to be in a block with a few thousand other transactions that this computer has received. And now the process of Bitcoin mining happens. So this block is being pieced together on numerous computers at the same time, but only one gets to say officially that this is the block. And that process is known as mining. And in order to be the person to confirm this block and get the Bitcoin and transaction fee reward, you have to guess an input to a hashing function to get a particular output below a certain number. There's a lot of information, but basically we have a function and we know the output, and we have to guess the input by incrementing what's known as a nonce. So this transaction is going to take some time. It might take 10 minutes or so for it to show up on the blockchain. That's because a new block is added on average about every 10 minutes. So what you can do is you can go to the Blockchain Explorer, and you can sit here waiting to see when your transaction shows up. Additionally, inside of Coinbase, you can hit View Details, and it says pending right here. If you come back, you'll come here and see that this says completed rather than pending. So if I go look at an older transaction where I've sent Bitcoin, you can see it says completed. And I can hit View Transaction, and the Blockchain Explorer pops up, and it shows this transaction. So while we wait for this transaction to be completed, we can explore the blockchain using some of my older transactions. So this transaction we are looking at, you can see that it's actually a part of a block. It says included in block 613263. So that's the block number. Each new block, that number is incremented, but you can select that and see the other transactions in this block. So scroll down, you can see there's a bunch of transactions, and in fact, there are 2,950 transactions as a part of this block. And one of the miners confirmed this, specifically Poolin, which is actually a mining pool, so it's a bunch of people put together their resources to confirm blocks, and then they split the reward based on how much computational power they contributed. All right, so let's go back to Coinbase and let's take a look at this transaction that is pending. And what you can see is that it still says pending, but it says confirmations 1. And basically each new block, this confirmations number is going to go up. So if we go to an older transaction, such as this one here on January 17th, you can see there's been 5,000 confirmations. So basically what Coinbase is doing here is it's saying that it's pending because it's only one block deep. But after each new block, it becomes harder and harder and harder to change the blockchain. And this is basically confirmed at a deeper level. So what we can do is we can view this transaction and see all the information. And you can see where the Bitcoin came from, as well as the address that we sent it to. There's this other address in here, which is like, we didn't send that. What's going on here? This is a concept known as change. Basically, an amount from the starting wallet is split up into this amount here, and then the rest is change that goes back to the sender. So the Bitcoin is essentially divided into two amounts, one that goes to the destination and one that comes back. So that's a little bit weird, but don't worry about that right now. The main thing that you want to see here is that the money was delivered, and it has one confirmation right now, and this was the total value, $11.19. And there is a fee of 0.000029 Bitcoin, which sounds like nothing, but if someone confirms a block with 3,000 transactions, those fees add up. That is the basics here. And what we can do is we can look at the block that it's included on and see the other transactions that are part of this block. So yeah, you can scroll through here and you could find ours if you really wanted to. And this is all public. So for example, you could go to this address right here and you would see the same exact transaction. Just good luck typing that all in. It might take a little bit of effort. But you can see here the confirmations is now 3. And what that means, if you go to the Bitcoin Explorer homepage by hitting this BTC right here, you can see that the one our block was a part of is right here, but there are now 2 blocks ahead of it. So our transaction is essentially in the blockchain 3 times. It started here, and then the hash of this is in this one, which the hash of this is in this one, and it becomes harder and harder to change the deeper it is. So if you're doing a huge transaction, like let's say you are selling a Lamborghini, right? You might not want to deliver that Lamborghini until a transaction is 6 blocks deep, or however much you feel comfortable. The general recommendation is that if something is very valuable, 6 blocks deep is considered really good. 1 block deep, it's not as secure, so you should probably wait a couple of blocks for anything worth a lot of money. If you're just doing something simple like doing haircuts or selling food or whatever it might be, you don't really need to worry about it because the chances of losing that money is very slim, and the extra stress of worrying about it is not necessary because it's very unlikely. However, for very large exchanges, you probably want to wait a few confirmations deep. Coinbase, I don't know at what point they say it's complete, but let's take a look here. All right, it looks like it's completed and there are 3 confirmations. So maybe it just waits till there are 3 and then it's like, we're good. I'm not entirely sure. And then on the wallet side, you should see this transaction as incoming Bitcoin to your wallet, and it's no longer associated with the exchange. So if you wanted to use another type of wallet, such as a hardware wallet, that hardware wallet's going to have an address for you to send cryptocurrency to, and you'll just send the money there and you're done. Now you can do this again for different wallets. So from your wallet app, you can send money to another wallet, or if you need to get fiat currency, you could basically send that money back to your Coinbase wallet by hitting receive here and sending to this address, and then you could exchange that for United States dollar. So you can start working with the money like normal money and get practice with that, and maybe get some practice with different types of wallets, maybe get a hardware wallet, maybe get a paper wallet, and just get experience with different things. So that is what I got on transacting with Bitcoin. See you guys in the next episode, because we're gonna touch on some more security things, I think, and I'll see you then. Welcome back, everybody. In this episode, we're gonna be taking a look at another type of wallet, as well as talking about some security concerns and just best practices when it comes to working with Bitcoin and your wallets. So some of that will be redundant from what we've talked about already. However, I just kind of want to get it all in one place now that you've got the basics kind of figured out. So the very first thing is I want to show you a cool website to get some practice with wallets. And this would be the equivalent of an online wallet, or what bitcoin.org would call a web wallet if you're going through their little help me find a wallet widget thing. And that is bitaddress.org. And the way this thing works is you kind of wiggle your mouse around to introduce randomness into the generation of a private key. So once this gets to 100%, there you go, you got a wallet. It's that simple. So basically, this is your private key, and this is your address. So the address is how people send money to the wallet, and this is how you confirm that you have ownership of the Bitcoin. This is like your password. Now you can read more about this in the text below. So this is a Bitcoin wallet. You can use this for exchanges. So there's a couple things you need to know though. For one, it's very simple. This is probably like the simplest wallet I have. So this is, I kind of think of it as the equivalent of like a sandbox website for development, like a JavaScript sandbox or an SQL sandbox where you can kind of test things out and play with it a little bit. I probably wouldn't recommend using this for any actual money for a couple of reasons. One, there's risk that the servers are viewing this information, or you're not getting an authentic version. So they talk about this actually, and that you can download the HTML and confirm that you got the authentic version, and it talks about how to do that here. And there is a SHA-256 hash available, and this is basically a way to confirm cryptographically that they are the same thing. So it's called a digital signature, and it's actually something used in Bitcoin a lot. But signing is also used to verify the authenticity of a particular download. And if you're really, really conscious about security, you can confirm the hashed version of what you have to the hash that they provide to the public. And if they're the same, then you have the authentic version. So we haven't really talked about hashes, but basically they take an input, they do some processing on it, and give you an output. That output is going to be the same no matter how many times you run that hash algorithm on the input data. It should give you the exact same output. If you change the input just a little bit, the output is totally different. So basically, if you have that output, you can confirm that things have not been changed. And that is actually used in signing with Bitcoin to basically say, hey, I have the authority to spend this Bitcoin because your private key is hashed with the transaction. It also mentions on here that your private key should be kept a secret. So obviously I'm breaking the rules here because you can see this private key, and you can kind of think of this situation as like a group wallet. Like anybody can add money to it and anybody can take money out of it just for experimental purposes, which is why I'm sharing the private key here. And in this situation, there's only one address associated with this private key. So basically you can take this Bitcoin address, copy that, and go to a Bitcoin Explorer, and you can paste that address here. Don't want all that extra information. And you can specify which blockchain you want, or you can just hit search. And notice here that there's a Bitcoin address, and then there's a Bitcoin Cash address. And we're gonna go into Bitcoin, and you can see that the total received and total sent is 0. So you can basically look up any address and see if there's any Bitcoins left in that person's wallet based on that address. Now again, some people will have multiple addresses and just use one address per transaction, and in that situation it's a lot more private because you don't know how much money someone has based off of just an address. Now it is the case that some people will use the same address to take in tips, for example. So if you want to put a donate link or whatever it might be, you can reuse that address. So for example, you even on this Blockchain Explorer, you can create a donation button, and if you look in here, you can see that it has the address put in there. So the address is going to be reused. And if you're using a wallet such as BitAddress, that's really the only thing you can do, at least with this single wallet. It looks like there's a bunch of different options on here, so maybe you can do something a little bit more complex. However, I haven't really done any of those yet. So the only thing I wanted to mention is that when you're reusing an address, it can reduce your privacy in a way. For example, here is a wallet that I found the address online, and you can see here that this person has received 571 Bitcoins, and if they're all around 10,000, we're talking about a whole lot of money here. Here's another one. This person has received 8,690 Bitcoins. In this situation, you can see that there is 0.21 Bitcoins left in this address. So this person has at least $2,000-ish worth of Bitcoin. So let's say you found an address with just thousands of Bitcoin in this final balance. That might make this person a target. Similar like if you were to announce that you had $10 million sitting in your house, that might make you a target. However, we don't necessarily know who this person is, but there are databases and different websites out there that try to associate addresses with people or organizations, and they do it quite well actually, based on where money is being sent or any information they know about a particular address. And then this data is all network graphed together, so you might not be as private as you think if you're reusing an address. But both of these were online public. They weren't hidden or anything crazy. They were just basically like, hey, if you want to donate, you can use this address. I have one even for my YouTube channel. I haven't even received anything yet. However, people can use that address and they can see all of the income that I've made from that. So when it comes to protecting your Bitcoin, there's a few things you need to do. One, avoid reusing addresses for everyday transactions. If you need to do like a tip jar kind of thing, it's probably not the end of the world. The majority of people watching this probably don't have hundreds of thousands of dollars worth of Bitcoin, so it's probably not a huge concern. But as you start increasing the amount of Bitcoin, the amount of security you need to take increases. And there's people who, they take their private keys and they put them in different lock boxes around the United States or the world, split up so that you have to get all of them to access the data. There's other people that probably just memorize all of their private keys and just trust solely on themselves to have that information. And there's probably all different kinds of layers of security that you can do. This bit address can certainly work for a wallet, although if you're going to use it for anything serious, you need to make sure that you have the official one and not record a video stream like me where you're sharing the private key with everybody. Don't do that. So if you have this private key, the funds are essentially yours and you can get access to Bitcoin and be able to spend it with just a private key. You guys can research how to do that. If you were given a private key or something, then there are ways to get that Bitcoin and spend it just using any kind of wallet app. Or if you're using a seed phrase, the same thing applies. Now I have 6 pieces on protecting your Bitcoin that we've talked about and maybe a couple new ones that I just wanted to review. The first is remembering that Bitcoin transactions are irreversible. So if you send money to the wrong person or you send with an extra 0 accidentally, you can't reverse that. So be very, very cautious. Number 2 is to confirm an address before you send it. Triple check with the person if you're working with large amounts. Talk to them in person and confirm that number. Copy and paste if you need, or scan a QR code just to make sure the address is correct. Third is to make sure you're sending to the right type of wallet, which is kind of tied with the previous one. Just make sure you know where you're sending your money. So if someone's like, yeah, dude, this is my address, and you triple check and you type it in exactly as is, but they're giving you the address for the wrong wallet, then that might end up with you losing money. Fourth thing is just to make sure that the person you're sending to has access to the wallet. So maybe you're working with some old information and you end up sending money to a particular address, but that person no longer has access to the private keys for that address. Well, then the money's gone, the person can't access it. The fifth one is just to be wary of any I didn't receive it scams. I'm just kind of making up that name, but basically you can go to a blockchain explorer and confirm that money was delivered to a particular address. If the person is saying they didn't receive it and it's on the blockchain explorer, they are lying, and don't fall for the scam and send them money again. And the sixth one is just be very cautious with any scammers because they're pretty much everywhere. Bitcoin is very cryptic and confusing, and people are taking advantage of the fact that people don't understand how it works and they're stealing people's money. So it should be obvious, just be smart. Don't listen to anybody in any comments section about being an expert or how they helped you make a bunch of money. Don't fall for any kind of money doubling or any kind of scams like that. If you have to send them money for you to get something like more Bitcoin in return or something, it's probably a scam. And just be very careful of the Bitcoin experts out there like myself making these courses. A lot of the experts out there are really trying just to pad their wallets with extra Bitcoin and extra money. So just be careful not to be taken advantage of. I'm not saying all courses out there are bad. Obviously, I'm producing a course here, but this is a very educational course, and I'm not necessarily giving you wild financial advice. And just a bonus tip, be careful of other things that we haven't really talked about, such as ICOs or any kind of new cryptocurrencies or new startups that are going to take over the world. A lot of them are scams, and just be very, very cautious and be pessimistic, I guess, with a lot of the stuff, because a lot of the ICOs, which are like initial coin offerings, which is basically when someone's starting a new company and they need you to invest Bitcoin or cryptocurrency for them to get it started, a lot of those fail, so don't fall for it. There are some valid ones, so you can research that if you want, but a lot of scams exist, so really watch out. And then lastly, just be careful keeping your keys, and overall, just be a smart person and you'll be fine. Keep in mind that Bitcoin is experimental and some of the kinks are still being ironed out, so don't invest maybe your whole life savings quite yet. Just like 75% of it. Not investing advice, I'm just kidding. Thank you guys, and stay tuned for the next episode. Hey, what's up everybody? This video, we're gonna be talking about Bitcoin from a currency perspective, if it's a good one, if it fulfills the needs of a currency, and we're going to approach this just by looking at currency in general. Now, forewarning, I am a computer scientist, I'm not a economist, I don't know, English, sorry guys, but I have done some research on this and listened to lots of podcasts and read books, so I think I can give some insight. But if you really, really need the details on Bitcoin and its monetary policy and all that junk, you can do your extra research. This is just an intro guide. What we're gonna do is we're going to look at a currency and talk about what purpose it serves and how to know if it's a good currency, and just talk about some of the ups and downs of the current currencies that we know of. Before studying Bitcoin and cryptocurrency, I really didn't care about what was behind our currency. And guys, I got some actual money here. So I didn't really care about how this worked, because all I cared about was that this bought me things I wanted. I could buy pizza or whatever it might be with this money. And that's fine. We can use the currency similar to how you can use Bitcoin without understanding confirmations and block size and all this fancy stuff. You can just use it. And that's a great start. But as you want to get into it more, a little bit extra helps. So what makes this a currency, and is it a good one? Well, first let's talk about what purpose a currency serves. And the primary thing is it's to facilitate trade. So let's say we didn't have currency and we were back in like a trading system, and I raised cows and I wanted to buy a gumball from you. What do? Do I give you just a slice of meat? Or what do I do to get this gumball from you? And you can quickly realize that trade is a limited system, because it's not easy to trade when you're just working with items. Because for one, the only currency I would have had would be cows, and cows go bad and you have to take care of them all the time. And other people might have other issues. If all you do is create gumballs, not everybody wants gumballs. So the idea of a currency is to facilitate trade. So whether it's money or coins or gold or feathers or whatever it might be, we can basically say, hey, I can sell meat for 100 bottle caps, and then I can buy a gumball for 5 bottle caps. And it makes trade a whole lot easier. So that's the purpose of a currency. Oftentimes, currencies do not have a whole lot of value in themselves. Like for a dollar bill, this is just paper with some ink on it. It doesn't actually have much value. But I can go spend it, because that person can then go spend it, and that person can go and spend it. So it's agreed upon that the dollar is worth something in terms of trade. But the actual thing itself is not worth much. And a lot of currencies work this way. Even things like gold doesn't have a ton of practical uses beyond a few specializations and jewelry. But it's it's often used as a currency. United States dollar is an example of a fiat currency. A fiat currency is a currency that the government says, hey, this is the official currency for our country. And the currency doesn't necessarily have to be valuable in terms of what it's made out of. Paper is probably, in my opinion, the most extreme example of this, where the paper is absolutely worthless, but the thing the paper makes up is extremely valuable. I can go buy a lot of stuff with $100. I could buy like 400 gumballs from a gumball machine. Gold is a little less of an extreme example because it has some practical purposes. You can use gold for jewelry, you can use it as a conductor in like electronics, you can probably use it for other things, but overall gold doesn't have a whole lot of uses, but it's still used as a currency. The actual gold itself might not be super valuable for uses, but people still accept it as a form of payment, usually. Now, you're not going to get paid in gold if you go get a job at McDonald's or something, and that's fine, but throughout time, people have used gold for currency. Is there a perfect currency? I don't know. See, there's some issues with the United States dollar. For one, it's super easy to create, and that is one of the problems with this. It's not easy for me and you to create, at least legally. However, the government can create as much of this as they want, and as they do that, they dilute the currency, and the $100 somehow becomes worth less. And we haven't even talked about digital currency, like a number in your bank account. This is sort of associated with physical currency because you can trade this for the money in your bank, or you can withdraw this from the bank, but you're really just working with numbers at that point. And this is even easier to generate out of thin air, even more so than just paper money. Banks can lend out more money than they actually have in-house, and as a result, they're kind of just making money out of thin air. Now again, I'm not an expert at this, but basically what I'm saying is that this money is very easy to create. Gold, on the other hand, is more scarce, and I personally believe that scarcity is an essential ingredient to a good currency. It should be hard to create new, and not just for the general public, but for everybody. If gold was the standard for the United States, the government couldn't just double the amount of gold, because there is a certain amount of work that has to go into getting gold. So scarcity for paper money and digital money in a bank account, the scarcity is very bad. For gold, it's pretty good because it's hard to get, and that can help make it a stable currency. This rolls over into Bitcoin because getting Bitcoin is actually very challenging. You have to compete for it, and it's very similar to the way gold works and is actually called Bitcoin mining, almost as if you were mining gold, but instead you're mining Bitcoin using your computer's processing power. Now, at some point you've probably heard of the gold standard or having paper money backed by gold, which is something the United States government doesn't do right now, but used to do. And basically you could take this and you could go trade it for a certain amount of gold. And this would basically allow us to use paper money, very convenient, without the risk of it being not scarce because there had to be gold associated with it. Now, I'm not going to go into the details of what form of currency is the best, but each one does have its pros and cons. In the situation of gold, gold is very heavy. It's also very hard to split. You know, it's probably kind of difficult to buy a gumball with gold. Or it's like, let me just cut my gold coin in like little tiny pieces. But with paper money and coins, we can do this very easily. Gold also takes up a lot of room, so if you were to transfer gold from one location to the other, that takes a lot of work. It's very risky, whereas paper money is very light, or digital paper money, or like bank account balances, is very easy to transfer. Almost instantaneous from one location to another. So gold is not necessarily the perfect currency because it has a lot of downfalls. Paper money is not necessarily the perfect replacement because it has a lot of issues such as not being scarce and being able to be created very easily. And the item itself has pretty much no practical use except to maybe start a fire. I don't know. Gold has also passed the test of time as it's been used for a very long time and it has always been seen as valuable, whereas pretty much every paper money in history at some point becomes not worth anything. Bitcoin kind of takes the pros of a lot of these different currencies and combines them together in one thing. So Bitcoin is scarce because it's very hard to get, but it's also very easy to transfer, so it's like a bank account balance. Also, Bitcoin is very easy to split. You can have fractional Bitcoin. So we get the benefits of it being like gold, but we also get the benefits of it being like a fiat currency. It's super easy to transfer, it's very easy to split up, but it's also very scarce, similar to gold. Bitcoin is an anti-inflationary system. Right now, there is new Bitcoin introduced every 10 minutes on average, but this rate of introducing new Bitcoins is slowing down every 4 years on average. So in the next 4 years, the Bitcoin rate is going to go down. Currently, 12.5 Bitcoins are released every single 10 minutes on average. And maybe even by the time I upload this course, that's going to be cut in half, because in the next month or two, it's going to go down to 6.25. And then 4 years from then, it's going to cut in half again. And it's going to keep doing that until 0. And that's in like a long time. We don't even have to worry about that right now. But at that point, there's a hard cap on the number of Bitcoin in circulation, and we can't really do anything to create new. So when there's no more Bitcoin being introduced into circulation, there will have been a max number of Bitcoin of 21 million Bitcoins, and that's going to be dispersed amongst everyone who owns Bitcoin. And a lot of those are going to be lost because people have lost thousands and thousands of Bitcoin. So let's say in theory, Bitcoin was the only currency being used, everyone adopted it. We would have to split up 21 million Bitcoin among like however many people are in this world, 8 billion or something. So one Bitcoin is going to be worth a whole lot. I'm not sure we'll ever reach that because there are other cryptocurrencies competing. Some countries aren't really fond of the whole Bitcoin thing, but that's the ideal world, and we'll see what happens. I don't know. Different cryptocurrencies have different rules on how the inflation rate works, like how many new coins are introduced, how often, and what's going to happen in the future. And you can learn all those differences as you study different cryptocurrencies. But that's your introduction to currency, and hopefully I helped put Bitcoin into context as to why it's so valuable. It's like digital gold. We get the benefits of gold, but it's digital. So thank you guys, and stay tuned for the next episode. Hey everyone, we are back, and in this video we are going to be talking about the Bitcoin network, and this is kind of the precursor to understanding Bitcoin mining. So the Bitcoin network is just a bunch of computers using the internet to connect with each other, and these computers are known as nodes. So compared to a centralized system where we might have one location for all transactions to go through, a decentralized system, these transactions go through all of these different nodes. And the more nodes we have, the more decentralized the network is. So the more nodes and the more people contributing to the Bitcoin project, the better. It can be a bit confusing because when you're using Bitcoin, you send money to someone and eventually it just ends up in their wallet. But how exactly does this process happen? Well, if we check out the Bitcoin white paper, you can get a little bit more information. So each node in this network has responsibilities, and this is what the node has to do. So when you spend Bitcoin, this is a transaction, and new transactions are broadcasted to all nodes. And as we talked about earlier, these transactions are put into a collection known as a block. Now, step 3 on here is where the mining part comes in. When a node finds a proof of work, it broadcasts the block to all nodes. This proof of work part, we're going to be talking about mining in the next episode in more detail, but essentially it has to go through some processing power to find what's known as a proof of work. And once that's done, that block is official, and it broadcasts that block to the rest of the network. Then the rest of the nodes accept the block if all the transactions are valid and everything's good. And then what all of the nodes do is they move on to the next block, adding transactions to that block, but they're using the block that was just confirmed as basically the input to this next block. So they're using the hash of the accepted block as the previous hash. So the hash of the accepted block is important for this next block in order to build the chain. Now this is how things work when everything is working just fine. There are some issues that can happen. For example, two nodes can broadcast different versions of the next block simultaneously. And in this situation, different nodes are going to get a certain one first. So now they have two variations. What are they going to do? Well, those blocks continue to work on the block that they received first. So in other words, if two blocks are announced simultaneously that are different, there's going to be a competition. Whichever one gets another block added to it first becomes the winner. Another thing is that when the transactions are announced, you spend money. It doesn't necessarily have to go to all of the nodes. As mentioned in step 1, it says new transactions are broadcasted to all nodes. Well, if it doesn't reach all nodes and just many nodes, well, eventually it's going to be put into a block whenever one of the nodes it reaches confirms a block. It wins the Bitcoin mining competition. So that's what the white paper is saying here. As long as they reach many nodes, they will get into a block before long. Additionally, if a node does not receive a block, it will request it when it receives the next block and realize it missed one. So in other words, if a node realizes there's a gap in the chain because everything is connected, it'll be like, yo guys, I think I missed a block. Could you send that to me, please? And then it'll put that in the right position and then continue working from there. So that was a lot of information, so let's just go through that one more time. You spend money, you create a new transaction, and that is announced to the network, and it reaches a lot of the nodes. These transactions are grouped into blocks by each one of these nodes, and they start competing for finding the proof of work or doing the Bitcoin mining part of this process, and one of the blocks is going to win. If more than one block wins, there's a little bit of a competition, but it naturally resolves itself. But let's just for now assume one wins. This new block is announced to the rest of the network, and the nodes are like, hey, we got a new block. They check to make sure everything is good, and they add that to their chain and build upon the next block using the hash of the block they just received as an input to the next one. Okay, I think we got through all that. Now you might be wondering, why would anybody want to do this? Why would you want to contribute your computer to be part of the Bitcoin network? Well, part of it is because there is an incentive. When you use your computer for Bitcoin mining, and let's say you are creating a block, well, that first transaction in that block is actually going to be a transaction that gives you brand new Bitcoin back into your wallet. So if you manage to successfully mine that block, you're going to get a bunch of Bitcoin in return. So basically you're trading your computer power for Bitcoin. Similar to how if you were to mine gold, you would have to put a bunch of work into that mining process, and it's going to cost you a lot of money for hiring people or for the tools. There's an expense to add more into circulation. So there's a software out there you should probably know about called Bitcoin Core, and this is going to download the entire Bitcoin blockchain. And when you do this, you are basically contributing your computer as a node to the network. At one point you could use the software to do the mining aspect of this as well, but now there is other software that you can use to do the mining part. So when you download the software on your computer becomes a node of the network and is used to validate the transactions on the blockchain to make sure everything is legit. This is what's known as a full node. When we're talking about Bitcoin, a full node is one who keeps the entire history of the blockchain on their local machine, and it can take up quite a bit of space, and it will continually grow as more and more transactions come into existence. So from bitcoin.org, you can hear a little bit more about the full node. Just to kind of restate everything we've said, a full node is a program that fully validates transactions and blocks. Almost all full nodes also help the network by accepting transactions and blocks from other full nodes, validating those transactions and blocks, and then relaying them to further full nodes. So it acts as the relay to get transactions and blocks throughout the network. So this is an important part. Many people and organizations volunteer to run full nodes using spare computing and bandwidth resources. In other words, there is not an incentive financially to be a full node. If you want the extra financial incentive, you can become a mining node. With a full node, your job is to validate transactions, make sure everything is legit, and then relay things to other full nodes. A mining node has a financial incentive because they have to do more work. Specifically, they have to do the mining process. So in exchange for computation, the Bitcoin miners get a reward of Bitcoin and transaction fees. So there are different things you can do to make more money with Bitcoin mining or to make any money at all. And we're going to talk a little bit about that in the next episode when we focus on Bitcoin mining. However, there is one more thing I wanted to talk about, and that is the concept of a lightweight client. So a lightweight client does not have the same power as a full node, and they are dependent on the full nodes. So there is trust from the lightweight clients in the nodes, but ideally this trust is better than the kind of trust we would have to have in a centralized entity because there are numerous of these full nodes. Lightweight clients, an example, is literally just your wallets on your phone. When you do a transaction, these transactions are announced to the full nodes. So that's what it's talking about when it says a lightweight client. And the last thing, which we're not going to get into a whole lot right now, is the concept of a pruned node. So this is similar to a full node in that it's used for validating transactions. However, it does not keep the entire blockchain record and just keeps like a certain amount, and as new comes in, out goes out, so you don't have to use all of your storage to store the entire blockchain. So if that's something that seems interesting to you, you can do the additional research, see if that's something you want to do, look into the limitations and the differences between a full node and so forth. That's your own little research project there. So that's all I got for you guys in this intro to the Bitcoin network. This stuff can be confusing, so if there's anything that needs a little bit more attention, let me know and we'll see if we can do some videos on it in the future. Now, let's go on to the next episode and talk about Bitcoin mining. Hey guys, welcome. So I know I mentioned we're going to be talking about Bitcoin mining, but I just decided, hey, we're going to hold up just a minute because I want to talk about some prerequisite knowledge that's going to make your life a whole lot easier. Sound like an infomercial here. Do you want to make your life a whole lot easier? Well, you need to study binary and hexadecimal and really understand how that works. So if you got that down, feel free to skip to the next section, but if you're a little shaky, this video will help you out. All right, so I have this spreadsheet open and I just want to illustrate how binary works. So with binary, you can only represent things with a 0 or a 1. So, for example, here we have a 0 and here we have a 1. This is using 1 bit, which is what each digit is called. So instead of calling it a digit, you would call it a bit. So in a 1-bit number, you can have 0 or you can have 1. But when you go to a 2-bit number, the total possibilities actually doubles. So you can have 0, 0, 0, 1, 1, 0, or 1, 1. And then the same thing happens when you add another bit. You can see there's a common pattern here. You still have that 0, 0, 0, 1, 1, 0, 1, 1, but now you have it for an extra 0 on the left and then an extra 1 on the left. So you basically have all the possibilities starting with a 0 and then all the possibilities starting with a 1. And if we did it again with 4 bits, the same thing would happen. You would have this entire pattern prefixed with a 0 and then this entire pattern prefixed with a 1. So as you add bits to a binary number, the total possibilities doubles. So you'll often see 2 to like a certain power. So for example, let's say we said 3, and we wanted to figure out what the value of this is. You can just use an equal sign. That's going to give us the value 8. So 2 to the 3 is a way to say how many possibilities for 3 bits. So this would be 3 bits, and the total possibilities is 8. So 2 raised to the 3rd power is 8. So if you wanted to know what 2 to the 32nd power is, you would just do 2 to the 32nd, and then you can evaluate that using the spreadsheet software. So 2 to the 32, we'll just type that in, and you can see we get this really large number here, which is like 4,294,967,296. So when we're talking about Bitcoin or the different pieces of Bitcoin when it comes to encryption or even hashing, there's often some number of bits associated with it. And when you have something like a 256-bit key, this is actually a really, really large number because we're talking 2 to the 256th power, which is like infinity. And oftentimes when we're representing these keys, having 256 bits can take up a whole lot of room on your screen. It's just not very easy to work with. So we often use hexadecimal to represent the data. Hexadecimal works in a similar way, but instead of base 2, we're now at base 16. So you have a 0, you got a 1, you got a 2, you got a 3, you got a 4, a 5, 6, 7, 8, 9, and then you have an A, a B, a C, a D, an E, and an F. So here's what that's going to look like. If I scroll over just a little bit, here I have the decimal number, the binary number, and the hexadecimal number. So 0 and 1 look exactly the same for all 3 of them. But once we get to the number 2, you can see it's represented like this in decimal. It's represented like a 1 0 in binary and a 2 in hexadecimal. Once we get down to 11, for example, or even 10, things start to change. 10 is represented with a 1 0 in decimal, a 1 0 1 0 in binary, and an A in hexadecimal. If you have a hexadecimal number and you want to see what the binary equivalent is, all you have to do is every time you see an A, you have to replace it with 1 0 1 0. And you do that for all of these different digits for a hexadecimal number to get the binary equivalent. So that is your introduction to binary and hexadecimal. The main thing you need to get from this is that if you have some kind of key for cryptography or for hashing, and if it's say 128 bits, it's a pretty big number. And if you go to 129 bits, you're not increasing by just 1, right? You're increasing it by 2 times the difficulty. So a 129-bit key is twice as difficult to guess as a 128-bit key. And then a 130-bit key is twice as difficult to guess as a 129-bit key. This is really important with something known as hashing, which is used in Bitcoin mining and just computer science in general. So you'll definitely want to understand this, and that's what we're going to talk on briefly in the next episode. So stay tuned. Hey, what's going on, everybody? In this episode, we're going to be talking about hashing, which is a super important concept to understand when it comes to Bitcoin mining, as well as various other computer science topics. So I'm excited to teach this, and I'm going to actually give you a little bit of experience that I've had with this and how I learned about hashing. So my first exposure to hashing was actually with databases, and we'll explain a good use for hashing, which will help you put it into context of how it's used in the industry, and then I'll talk about how this applies to Bitcoin mining. So with a database, in the specific example of wanting to store a username and password, when you create an account on a website, that information is stored in a database. That way they know how you can log in. You know, you have to put in the right username or the right email and the correct password. But database people, software developers, are very hesitant to put passwords in plain text where anybody can just read that data. So we need a way to basically mask this data, and we do this through hashing. So let's say we have this very secure password of password 1, and we hash this data. The output is illegible compared to the input. So we have some output that's just random numbers, random letters, and it doesn't mean anything based off of the input. And if we change the input just a little bit, that hash is completely different. So then if someone breaks into the database and they look at the passwords, they are not able to get the original data. However, there's one useful thing that makes this work, and that is if you run the same password, you're going to get the same output. So you can check if a password is correct by hashing it and seeing if it matches the content in the database. Now, this isn't a perfect solution because there's various issues such as rainbow tables, which is basically a table that hackers use that says, hey, these common passwords have these hashes. And that can basically invalidate the hash. So we do extra work. We add a little bit of extra information to the input, known as a salt, which changes the hash. And then the hacker would have to know what that extra information is to get the hash. And you can see it gets pretty complex pretty quickly, but let's just keep it simple and go through an example. So you can think of a hashing algorithm as a function. This is an example of a function with parentheses that takes input. So we are hashing the word hello, and we are getting a 256-bit output. So when we run this using MySQL database, what do we get? We get this output right here. And this is represented in hex. It's 256 bits, but the output is in hex, and we talked about that in the previous episode. So a 256-bit output is going to be 64 characters in hex, because every 4 bits coordinates with one hex number. So the hashing algorithm we are using in this situation is called SHA-2, specifically 256 bits, so you might see this as SHA-256. It's a form of SHA-2, which is like a family of algorithms. We could also do other bit length, so 224 is an option, and in this situation, the output's not going to be as big. We could also go a little bit extreme and go 512. And in this situation, that's going to be twice as many character output as the 256-bit option. See, it's pretty long. 256 is probably the most common, and that is what is used in Bitcoin mining. And here's what I want you to realize. When I hash this word hello, you can see it starts with 2CF and ends with 24. And when I run it again, it still starts with 2CF and ends with 24. So the output is exactly the same no matter how many times we run this function. So if we're trying to guess a password, we can confirm the input by running it through this hash algorithm and see if we get this value, which would be stored in the database. So all of that rambling just to say that the magic of a hashing algorithm is that you can easily confirm the input, make sure things match, but you cannot easily guess the input. It's almost impossible to guess the input. If I gave you this hash right here and I said, yo, I want you to tell me what input gave me this hash, you would have a very, very difficult time, assuming you didn't know the hello was there. So if you don't know the input, reversing the process is extremely difficult. So in Bitcoin mining, you have a hash sort of like this, and your job is to guess the input, and you don't actually have to do it. Your computer does all of the work, so there's software that does the guessing. You have to guess the input to get the correct hash value. Not exactly the hash value, but you actually have to get a number less than the hash value. So this hexadecimal represents some number. If you guessed an input that got a number smaller than this in the context of Bitcoin mining, you would win. And that's what we're going to get into in the next episode. So hopefully this makes things nice and clear. Stay tuned for the next episode. Hey, what's going on, everybody? This is a video probably many of you have been waiting for. We're going to be talking about Bitcoin mining and how it works. And yeah, it's going to be pretty fun. So I'm actually pretty excited. So in the previous section, we talked a little bit about hashing. And basically with hashing, the input turns into something totally different. And the output length is always the same. In this case, we're doing 256 bits. And the thing is, if you do the same input through the function, it's always going to give you the same output. So creating that output is very simple when you have the input. But without the input, it's very, very, very difficult to get that input. So if I gave you the output and told you to give me the input, you would have to put a lot of work into figuring out what that input is. And that's exactly how Bitcoin mining works. Essentially, Bitcoin is set up so that you have to put work in order to confirm these transactions that are being made. And when you do that, you get rewarded Bitcoin. This is an example of what's known as a consensus mechanism. So it's basically a way that people agree on what's the official transaction ledger. So if you go to a blockchain explorer, this here is the official blockchain for Bitcoin. This is what all of the nodes have agreed upon. And it's essentially a ledger, which is used to keep track of all the transactions that happen. We've talked about this and you've probably seen this explorer numerous times by now. But the question is, how do we get all of these nodes in the Bitcoin network to agree on what the official blockchain is going to look like? This concept is known as consensus. The consensus protocol of choice for Bitcoin is called proof of work. And just like with hashing, it's very, very difficult to guess that input. The same thing is with proof of work. A proof of work is a piece of data which is difficult to produce, but easy for others to verify and which satisfies certain requirements. So in this wiki, it actually gives really good examples of how hashing works. And there's additional information added into the input called a nonce. And basically, we start with a message such as hello world. This is just a really simple example. Bitcoin's is a little bit more complex, but once you understand this, it's very simple to move on to the next section. So hello world, and we put a 0 at the end. Hello world, and then we put a 1 at the end. And each time, we get a completely different hash. And that is how hashing works. We talked about that already. And the thing with Bitcoin mining is that we're doing the same exact thing. We're incrementing this nonce, and we're going to keep doing that until our hash is below a certain value. And I'll explain why in just a minute. Why is it below a certain value? In this little example here, we're looking for a value smaller than 2 to the 240th power. It goes through some examples here. The first one is 2 to the 252nd. We got some other ones, 200 to the 255th, again 2 to the 255th, and eventually we finally get one that's 2 to the 239. So if you look at the actual hash value, you can see there's numerous zeros at the beginning. And since the ones on the left contribute the most to increasing the value, when we're looking for a small number, there's going to be more and more zeros on the left. So in this situation, it took us 4,251 tries, because we started at 0, to get the right answer. And the answer we were looking for is any number smaller than 2 to the 240th. So this number here on the right, it's just the decimal representation of this hexadecimal value right here. So this is actually a really simple example, but it illustrates how Bitcoin mining works. We have some set input, in this case hello world, and then we have the nonce, which we increment. And everybody is trying to figure out a certain number under a target value. The first node to do this is the winner, and this node is rewarded Bitcoin in exchange for the work that the node put in with the processing power of the computer. So each node is going to be working individually to figure out a number, and it's going to be unique for each individual node because there's a special transaction that changes the input for each node, and that transaction is called the Coinbase transaction. And this Coinbase transaction is where certain number of Bitcoins are transferred to the node that found the correct answer. In Bitcoin mining, the input is not a simple string like hello world. Instead, we have the time, we have a summary of the transactions that are in that block, we have the previous transaction as an input, so that gets hashed and we use that as an input, which makes it a series of blocks that are connected. And then the last thing is the nonce, which is the number that we increment to try to get a hash value under a certain value. Taking a look at the Blockchain Explorer, we can look at any block, doesn't matter which one, and what you can do is you can scroll down and you can see this first transaction. It says Coinbase, newly generated coins. And in this situation, it's a little bit over 12, it's about 12.7. And I can explain where that number comes from. If you just scroll up a little bit, you'll see that there is a block reward of 12.5 Bitcoins, and then there's 0.28 Bitcoin as well, which is the fees of all the transactions. This is rewarded to whoever mined this block. In other words, the first person to get the hash output under a certain number. And the answer for the miner here is Poolin. We've actually seen this earlier in the series, I believe, and this is actually an example of a mining pool. So people put their resources together in order to increase their chances of winning anything. We can go look at the nonce for other blocks, so let's go back a page. Let's just check another random one. In this situation, this is the nonce, 1,962,000,000. Let's take a look at this one. This one is 2,264,000,000. So this person had to guess a whole lot of different inputs to get the correct output. Now you might be wondering, how do I actually mine? Well, we've talked about Bitcoin Core, and I believe at one point you could mine with that software, but that's no longer a thing, and instead you get dedicated mining software, and there are a lot of options out there. So you can look up best mining software, or maybe you're on a particular operating system that has a certain software that's best for it. Maybe you're on a mobile phone, maybe you're on Linux. Whatever it might be, just look up the different mining softwares and see which one resonates the best with you. For example, here is multiminerapp.com. This seems like a pretty good mining software. You can access it on mobile devices, or you can download it on Windows, Mac, or Linux. So that's just one example. You just download it and then you just start running it, and your computer will start processing stuff. Now, if you're just an individual person, the chances of winning at Bitcoin mining are very, very slim. That's because so many different people are competing for that Bitcoin reward. That's because 12.5 Bitcoin right now is worth like over $100,000. That 12.5 reward is going to go down over time. It's going to halve to 6.25 really soon, and then it'll just keep going down from there. But there are still going to be fees, so that will still incentivize miners to continue mining Bitcoin. If you want to get a little bit of a reward, you can join a mining pool and you can research which ones are best. They have different fees or different ways of calculating how much you get, but you can join a mining pool and you will be rewarded probably percentage based on how much computational power you contributed to mining a particular block. And then the money that is received is dispersed among the people that have contributed. So that is an alternative if you want to start getting money right away and not be so risky contributing forever and not winning anything at all. Now, all that being said, you might wonder, is this worth it? Because running a computer actually uses a lot of power. It generates a lot of heat and has to be cooled. And so many different people are competing for this Bitcoin that it's extremely competitive. So as a result, there's different things you can do to make it more profitable. Now, this is not a course on Bitcoin mining, so we're just going to scratch the surface here, but there is specialized hardware that you can use known as ASICs, which is basically a chip designed for Bitcoin mining. You can also do Bitcoin mining in areas that are cooler because the heat is not so much of an issue, and you can do it in places with cheaper electricity. Anything you can do to lower your upfront costs can help you make more money. And there's actually a lot of different calculators out there that you can put in how much hashing power you have and what the cost of electricity is, and they can help estimate if you're going to make any profit. A lot of different cryptocurrencies work in a similar fashion with proof of work as opposed to the other consensus mechanisms like proof of stake. So if you want to do Bitcoin mining, but Bitcoin mining is not as profitable as you might like, you can look into other cryptocurrencies that you can start playing with and start mining and getting a little bit of that cryptocurrency. Some stuff that's not nearly as competitive, but might not have much value. Now, another thing before we go is that the algorithm that Bitcoin uses for the proof of work is called Hashcash. And it's essentially going to use SHA-256, which is what we talked about when we were talking about hashing, but it's going to do it twice. So whatever the output is, it's going to put that through SHA-256 again. So in the wiki, if you take a look at Hashcash, you can see in here SHA-256 to the second power. In other words, we're processing it through SHA-256 twice. This is possibly to prevent something known as a length extension attack, which you can research if you want to know more about that. But it's just good to know that we're using the SHA-256, but we're doing it 2 times. So that's your introduction to Bitcoin mining. There is so much more we could talk about, and maybe that is a course for another day we could do, and we could set up a Bitcoin mining rig and get all into it. But I think that's a pretty good introduction for now. Thank you guys for watching, and now we're going to be talking about some different attributes of the Bitcoin blockchain. So I'm looking forward to the next video. I hope you guys are as well, and I will see you there. What's going on, everybody? In this episode, we're going to be talking about various attributes of the Bitcoin blockchain. And this is tied to Bitcoin mining, so make sure you watch the previous section because that's where we're talking about how Bitcoin mining works and also a little bit about the difficulty of Bitcoin mining. But I really want to dive into the difficulty part right now. Now, I showed you this example in the previous section that illustrates a little bit about how Bitcoin mining works. Basically, you are guessing the input by incrementing this nonce to get a value under a certain number. So in this situation, we're looking for a number under 2 to the 240th. So this number determines how hard it is to guess that input. If we have a very large number, it's much easier to get the correct value that's under that number. If instead we're trying to guess something smaller than 2 to the 20th, that's going to be practically impossible because all these numbers are so huge. It's going to take us a really long time to get that number. So what happens is Bitcoin adjusts this difficulty level, and I'll explain the reasons why that happens, but the difficulty is going to go up and down over time. This number here is known as the target. It's a 256-bit number, extremely large, in case you guys didn't know that yet, and it gets adjusted every 2016 blocks, which is about 2 weeks. So every 2 weeks, the difficulty of Bitcoin goes up or down. You can actually see charts of how difficult Bitcoin is at the moment. So for example, at blockchain.com, you can find the chart of the current difficulty. And if we go to all time, you can see that the difficulty has pretty much gone out the roof. When we started, it was obviously very, very low because there was very, very, very few people using Bitcoin and people were really unsure the future of it. So there wasn't a lot of people mining Bitcoin and supporting the network. Then people started to think Bitcoin was valuable and more people started to mine it, and the difficulty went up over time. Now, why is it that the more people who mine Bitcoin, the more computational power the Bitcoin network has, the difficulty goes up? Well, it is a way to enforce equilibrium of creating blocks on average every 10 minutes. So if you take a look at a blockchain explorer, such as the one with blockchain.com, you can look at the times here and realize there's about 6 every hour. Sometimes more, sometimes less. For example, there's only 4 an hour ago, but it seems on average it's about every 10 minutes. This is known as the block speed, and Bitcoin is set at 10 minutes. So what that means is that if blocks are being created faster then every 10 minutes, the difficulty is going to go up to force the time to slow down back to 10 minutes. If instead people are mining too slow and blocks are being created every 20 minutes, the difficulty is going to go down so that the speed picks back up. So in a way it's cool because it keeps the time of 10 minutes the same over time, but it's also very inefficient because if right now everybody started mining Bitcoin, the difficulty would skyrocket, but the actual production of one block every 10 minutes would stay about the same. So more work in does not mean more work out in this situation. Twice as much work in means the same exact output of a block every 10 minutes. We're just going to be making the mining process twice as difficult. You can go into one of these blocks and you can see the difficulty right here. So whether this difficulty is 1 or a super huge number such as this, it still took just the same amount of time to create this block. So that's why a lot of people have issues with Bitcoin. When it comes to the environment and power consumption, Bitcoin is said to be very inefficient. And part of that is because they're trying to mimic the process of mining gold. There has to be work put into it. People argue that proof of work is the best consensus mechanism. However, when it comes to mining, the difficulty can continue to go up and there's nothing extra being produced. And on top of that, another important thing you need to understand about Bitcoin is that the reward is being halved every 4 years. So in this situation, the block reward is 12.5. By the time you're watching this, it may be 6.25. In other words, it's going to get cut in half. And this continues to happen every 4 years until the block reward is 0, and then we're living just off of the fee. So when Bitcoin first started, the reward for mining was 50 Bitcoin. That cut down to 25, and then that cut down again to 12.5. However, the difficulty has continued to go up and up and up. So the average return for each computational cycle is becoming less and less in terms of the number of Bitcoin in circulation. So where is this going to go? We don't really know, and a lot of people worry about it because Bitcoin, the network, is consuming electricity on the scale of small countries, but there is a possibility that this will calm down. So for example, as the reward right here is being cut in half and half and half, people are going to be less incentivized to mine Bitcoin. Once this becomes so low and we're living off purely the fees for mining, maybe the difficulty will start to go lower. If the difficulty goes low enough, then maybe mining for just those fees will become worth it. I don't really know. I guess we'll just have to find out how things go in the future. So tied to the concept of block speed is the number of transactions per block, or the block size. So a transaction takes up a certain amount of space. Space meaning storage on a computer. And each block has a limit to the size of the block, so it can only hold so many transactions. So when you look at a block, you'll probably see something like 2,000 to 3,000 transactions. And that's pretty normal. But here's the thing, as more and more people start to use Bitcoin, what's going to happen? If we can only fit like 3,000 transactions per block, how is everybody going to use Bitcoin? Well, that's a thing. That's where the fees come in. These fees act as a way to force your transaction to be confirmed as opposed to other people who are paying less fees. A lot of the wallets that you're using just automatically do the fee part for you, but some wallets allow you to configure the fee, so if you really need your transaction to go in, you can up that fee. So it might just be that as more and more people use Bitcoin, the fees go up and the block reward goes down. I don't know, it's hard to say. All we really do know right now is that Bitcoin mining is extremely competitive, and when this really became a thing, the price of graphical processing units pretty much doubled, and then came chips specifically designed for Bitcoin mining, and the playing ground just becomes more and more competitive. People are building server farms, and it's no longer just people working on their laptops mining Bitcoin. It has become a large-scale way of making money if you do it right. As a result, it's very difficult to make money as an individual, and if you ever plan on making money, you'll probably have to join a mining pool. I'm really curious, 10 years in the future, what this is going to look like. Is Bitcoin mining going to be profitable at all? Are people going to lose money mining Bitcoin? Some people mine Bitcoin just with the thought that the coins they mine are actually going to be worth more in the future, so they are willing to break even or maybe even take a loss because they're really confident in the ability of Bitcoin growing in value. This speculation could be dangerous. It could be really good for these people. It's really hard to say. So I would like to know what your thoughts are. Let me know what you think the future of Bitcoin could look like in terms of energy consumption, difficulty mining, block rewards and fees, and overall the transaction limit, how are we going to process hundreds of thousands of payments? Bitcoin is actually pretty slow in terms of the number of transactions compared to centralized money exchanging services. So Visa is processing way more transactions than Bitcoin. From my perspective, it seems that Bitcoin could be a solid currency. It is still experimental, but a lot of people are heavily invested in this, and it has stood the test of time, at least so far. However, some of these limitations might really become limitations in the future, and I think that's something we'll have to find out and see what happens. There are other cryptocurrencies that supposedly help solve this problem, and that is what we're actually going to be talking about in the next section. So stay tuned for that one. Hey, what's going on, everybody? So throughout this entire series, we've talked about pretty much everything Bitcoin, and we've also talked about blockchain, but there's so much more than just Bitcoin. In blockchain, the only use for it is not Bitcoin. One, it's used for other cryptocurrencies, also known as altcoins, or just coins that are not Bitcoin, but it's also used for numerous other things. So there's so much more that we have not talked about. One thing we're going to touch on in this video is learning a little bit about those altcoins and some of the different options out there. So the first thing you need to realize is that not everybody agrees on everything. You know, there's die-hard Bitcoin fans, Bitcoin users that believe it has to be a certain way, and then there are other users that feel it needs to be a different way. So issues such as block size or block speed or whatever it might be, these cause debate. And as a result, there have been some splits in the growth of Bitcoin. Technically speaking, these splits are known as forks. So when a cryptocurrency has a fork, what happens? One of two things. There could be a split and people continue to use the old version as well as the new version. Alternatively, there can be a split and the old version fades away and people focus on this new path. Well, there have been some hard forks of Bitcoin where there's a split and they both continue to exist. So there is Bitcoin, but there is also another common cryptocurrency, Bitcoin Cash, which is a fork of Bitcoin. There are other ones out there, but once you understand how one works, you can pick up these other forks much easier. So Bitcoin Cash is the one I want to focus on right now, and this has some different things that are proposed as fixes to the original Bitcoin. One thing, and this really isn't a competitive thing here, but Bitcoin Cash is worth $354 at the time of this video, so I'm also very curious when you're watching this what it's going to cost. But you can check out their website at bitcoincash.org, and what Bitcoin Cash is proposing is a solution to frequent exchanges of cryptocurrency. So the fees are much less. And it says here that any Bitcoin holders as of block 478,558 also owns Bitcoin Cash. So when this split happened, everyone who had Bitcoin now has Bitcoin Cash. Lucky you guys, you pretty much just doubled your cryptocurrency. This is another way people make money with cryptocurrency, is with cryptocurrency forks. And just like there is a blockchain explorer for Bitcoin, there is also a blockchain explorer for Bitcoin Cash. And the ticket that you're looking for is BCH. So ticket meaning the shorthand of the name. Bitcoin is BTC, Bitcoin Cash is BCH. So on blockchain.com, instead of selecting Bitcoin, you can select Bitcoin Cash. So you can go in here and explore just like you would with Bitcoin. You can open a block, you can see the number of transactions, and you can see the fee reward right here. So go ahead and do some exploration and just check out Bitcoin Cash and let me know what you guys think. I don't really know a whole lot about Bitcoin Cash. I've started with Bitcoin and now I'm just kind of exploring the alternate options to this. But Bitcoin Cash seems like a possible good one, so yeah. Now another cryptocurrency you need to know about is Ethereum. And this is not a fork of Bitcoin. In fact, it's its own cryptocurrency and it's different than Bitcoin. However, it's still built on a blockchain, so a lot of the principles still hold true. The thing with Ethereum is that it often attracts developers and people that like to build things because you can create things known as distributed apps. Distributed apps are just applications built upon a distributed system such as blockchain. And Ethereum has really brought popularity to something called a smart contract, which is basically a small contract in code that can force a transaction if certain requirements are met. So it basically allows for microtransactions to be programmed in software, and it's a new paradigm of building applications. On top of their blockchain network, they also have their own cryptocurrency, Ether. So you'll probably want to look into that and start studying up on Ethereum as well. And maybe I could do a course dedicated to that, but we're just going to touch on it for right now. The magic with Ethereum is that they give developers access to program on their blockchain, and as a result, a lot of people have created their own cryptocurrencies on the Ethereum network. And these cryptocurrencies are special cryptocurrencies known as tokens rather than cryptocurrencies. I mean, they're still kind of classified as cryptocurrencies, but most people say tokens. So this is the Ethereum website, and you can go in here and you can get guides for how to do all of these things, such as smart contracts. You can go in here and there's guides for all of that. You can also find Ethereum explorers. So back to the Blockchain Explorer, we're going to go to the home page, and on the left, we're going to select Ethereum. Now notice the block speed on here is much faster. We have numerous every single minute. We can go into one of these blocks and see that there are 163 transactions, and the reward and the fee is just totally different than Bitcoin. It works a similar way to Bitcoin, but it's its own thing. Now I actually prefer a different Ethereum viewer, so I'm going to show you guys that now. This is etherscan.io. I think it's a little cleaner. You can go in here and you can see the latest blocks. We'll click one of these. And then what you can do is you can hit 68 transactions. And what you can do is you can see some of these other tokens in these transactions. So for example, one of them in here is Tether. Tether is actually a different cryptocurrency. It's a token that's built upon the Ethereum network. Here's one for ENQ token. And you can see this has a price. You can go buy this cryptocurrency, but it's all built on the Ethereum blockchain. So you can see how Ethereum has really opened the doors for a lot of new crypto tokens and a lot of new development. It's actually pretty exciting. Now there is going to be debate about solid Bitcoin fans versus Ethereum, about which one's better or whatever. I'm not going to get into that today, maybe another day. We're just taking a look at the landscape and just seeing what's out there. Now there is one more cryptocurrency I want to share with you guys, and that is Ripple, or XRP. And this one is completely different than the others. Bitcoin and Ethereum, these are built on a public blockchain, and anybody can create a node and join that network. Ripple is instead a private blockchain in that you need permission to join this network, and this is a company. Things work a little bit different. But Ripple is really involved in the banking space, trying to change the way transactions happen in the current banking system. So I don't know anything about Ripple right now, but just wanted to throw that out there, guys, that there are different types of blockchain networks out there. They're not all public, and they don't all work exactly the same as Bitcoin and Ethereum. Whew. So that was my introduction to altcoins and just getting a little taste of what's out there. Hopefully that was helpful for you guys. Let me know what other cryptocurrencies you think are cool and what you'd like to see me cover in more detail. I think Ethereum would be a good option, but we'll see. Thank you guys, and I will see you next time. Hey, what's going on, everybody? In this episode, we're going to try to cover what would probably need an entire course to truly understand in depth, and we're going to try to do it in one video. What are we going to be talking about? We're going to be talking about keys and cryptography and digital signatures and all of this stuff that makes Bitcoin possible. We're going to approach this from just a cryptography standpoint. So before we talk about Bitcoin, let's just take a look at cryptography. So the start of modern cryptography is something called symmetric key cryptography. And the way this works is I can give you a message and you can read this message if you have a secret key that allows you to decode it. If you don't have the secret key, then you can't read it. And that key is the same key I use to encrypt the message. So this key is called a private key. The private key is used to encrypt the message, and the private key is used to decrypt the message. The private key could be, as an example, a 128-bit binary number. And you would have to know this binary number in order to convert the scrambled message back into something readable. So I take this key and my message, combine them together, I have some completely unreadable junk, and I hand this to you, and you also have this key, so you add that key to the messed up junk, and it comes back to readable messages. That's how symmetric key cryptography works. It's called symmetric because the key used to encrypt and decrypt is the same. To visualize this, let's say Bob is trying to send a message to Alice. He says, "Hello, Alice." He encrypts that using the secret key, and it becomes this sequence of characters that means nothing. Alice takes that message and decrypts it using the same key and gets hello Alice. If someone intercepts that message halfway through, like right here, before it's decrypted, they're not going to be able to read that message unless they have that private key. The next type of cryptography you should understand is asymmetric cryptography, also known as public key cryptography. In this situation, everybody's going to have a public key and a private key. The public key is something they're totally fine with giving out to people, but the private key is kept a secret to the person who is going to be receiving messages. So in this situation, the public key is used to encrypt the message, and the private key is used to decrypt the message, which is why it's called asymmetric cryptography. The key to encrypt and decrypt are two different keys. Anybody can take the public key and encrypt a message, but only the person who has the private key can read it. Here is a visual representation of how this works. Bob wants to message Elise. Well, he is going to use Elise's public key because he knows she'll be able to decrypt that. So he uses the public key, sends it over to her. Now it's a scrambled message, and she can decrypt it using her private key. Is it Elise or Alice? It's Alice, isn't it? I keep getting this name mixed up. Alice. So in this situation, Bob does not have to know Alice's private key. Now you're probably wondering, why in the world am I explaining all of this junk? Well, the symmetric cryptography was just kind of a build-up to understand public key cryptography. And that's what we're looking at now. And the interesting thing about public key cryptography is that you can actually flip it and do something known as a digital signature. In this situation, you use your own private key whenever you send messages. And whoever receives them can confirm that you wrote those messages using your public key. That's because the private key and the public key have some kind of mathematical relationship that they fit together, but you can't always figure out one from the other. So if you have my public key, you can't figure out my private key, but you can use my public key to see if I actually sent the message with my private key. And this concept is known as a digital signature. And if you want to know how it works, you can research how digital signatures work, but complex algorithms make this possible, and the fact that the keys are mathematically related. So here is what that's going to look like. If Alice is trying to send Bob a message, but she wants Bob to know that it's coming from her and not a stranger, well, she signs it using her private key, and then Bob can verify it using her public key. If someone else signed it with a different key, and Bob's going to know right away that someone is trying to forge Alice's signature. And what can end up happening is you can have a combination of this public key encryption as well as the digital signature. So let's say Alice wants to reach out to Bob, but she wants Bob to know it's from her, and she wants the message to be encrypted. What she can do is she can encrypt it with Bob's public key, and she can sign it with her private key. And then Bob gets it, confirms it's from her using Alice's public key, and then decrypts it using his private key. So it's pretty complex, but that would be the ultimate level of security there, because you know where the message is coming from, and you know that if anyone was to intercept it on the way, they wouldn't be able to read it. Only Bob can read it, and only Alice can send it. Perfect. This concept is applied in Bitcoin to verify if people are able to spend money they're spending. So if someone's trying to spend money they don't have or spend someone else's money, this can easily be stopped using digital signatures. So the algorithm that makes this possible is called Elliptic Curve Digital Signature Algorithm, or ECDSA. Elliptic curve cryptography is a type of cryptography, and you can research that more if you want, but it's an advanced algorithm that makes these signatures possible. It's basically an example of a cryptography algorithm, similar to RSA or DSA, which are two other encryption algorithms. So in Bitcoin, someone with the private key that corresponds to funds on the blockchain can spend the funds. In Bitcoin, a private key is a single unsigned 256-bit integer. With the way the private key and the public key are mathematically related, the public key can be calculated from a private key, but not vice versa. So what am I even trying to tell you guys here? So you know, when you have a wallet, you have this private key. You're not supposed to tell anybody. You also have a public key. When you spend Bitcoin, your public key is exposed, and that can be used to basically confirm your private key without giving your private key away. Similar to this photo, how Alice can use her private key to sign a message, and it can be confirmed using her public key. So now again, in Bitcoin, the public key allows us to confirm that the correct private key was used without exposing what the private key value actually is. So this is interesting because when you spend Bitcoin or you send it somewhere, the public key is exposed, and this article here says that your public key does not need to be kept secret. However, it's not best practice, as we mentioned earlier in this course, to reuse addresses. Addresses are an additional layer, so your private key gives birth to your public key, which gives birth to your address. If you're reusing addresses and your public key gets out there, that's one layer closer to your private key. So although giving out your public key doesn't expose your private key, it is one step closer than the address, which is a little bit farther from your private key. So when you're working with a wallet, you're probably not even going to see your public key. You're pretty much just going to be working with your private key or your seed phrase, and then you'll be using addresses for transactions. And the only other thing on this article that you need to understand is the signature, which we did talk about a little bit with signing a message that you're sending to confirm it came from you. This also uses a hash, so hashes aren't just used in the Bitcoin mining, they're also used in the signatures. And basically, what is it going to be hashing? It's going to be hashing something to be signed plus a private key. So you take your private key, you take whatever you're trying to sign, and these go through a hashing algorithm, and that is how we protect your private key. And that is pretty much your introduction to private keys, public keys, and addresses, which are like a step farther away from your private key, and signatures, which are used to confirm that you can spend your Bitcoin. This is why your private key is so important, because it's basically literally the key that can unlock spending your Bitcoin. So don't give it out to people. And that is your message to learn from this entire course, is don't give away your private keys. Well, hopefully this was helpful for you guys, and I'm actually really excited for what else is to come, so stay tuned, and I'll see you all soon. Thank you guys so much for joining me for this course. I would like to know from you, what other topics would you like to see in this course or in separate courses in more depth? If you're looking for other things to research, here's what I would suggest. First, I would build a familiarity with the different consensus mechanisms. So some of the different blockchains will use a different consensus beyond proof of work. Maybe you should understand how these things work. I would also focus on some of the altcoins. I would really look into Ethereum and start looking into smart contracts. If you're into development or building distributed applications, this is where you would want to start. And if you're really getting into Bitcoin because you're looking for various ways of investing, then my next logical step is to look into Bitcoin trading. So this is something where you might buy and sell Bitcoin numerous times a day, rather than just buying it and holding it for who knows how long. In this situation, you're going to need to learn a lot about different investing techniques, and we didn't exactly cover those in this course. So if you want to go down that route, look for an exchange that gives you a lot of advanced features and can give you more substance than this introductory course. And maybe we'll have an investment course in the future, who knows? Now to conclude, I just want to say thank you for joining me. Thank you for sticking through this entire course. Please let me know what you thought, and let me know if there's anything I need to add. Maybe I can add a bonus section with just a couple more videos to make it more complete. Thank you guys, and I will see you in the next one.